Hello.
Yes, sir.
Am I
Yes,
audible?
sir.
Good evening, sir.
Good evening, sir.
Yes, sir. Yes, sir.
Okay, so okay, all right. So, how many of you covered the uh, some lectures from week 12? I think there are how many lectures? Around seven, right? Seven or six.
Yeah, sir.
Yeah, 6 or Yes, sir. 7.
Yeah, right. So, how many of you covered at least three? Just simply
Me,
raise.
sir.
Okay.
Not yet covered, sir.
Week 11.
Week 12, right? So, week 11, I think due date is already done.
Yeah, sir.
So, I can
Oh.
see some 4 to 5 entries. Okay. All right. Not a problem. So in week
Sir,
12,
sir,
yeah,
hello.
yes, yeah.
Sir, activity board in extra activity for peer review button is not visible in my
No.
index.
Just do a refresh that was issued during
Yeah,
evening.
I am also refreshed when
It's not
more
working
than
for
2 times.
me.
Not working. Yes, sir.
So I think in the evening
It's working, sir, for me.
It's now working.
Yes, sir. It's working
It's
for
now
me now,
working.
Peer,
sir.
sir, peer button is not
Oh.
that's why I'm
It's
saying
available in
now
my
okay.
They,
Abhishek, we got info
yeah, they have
uh,
sent an email that it's now like the
not
problem is
response in
resolved, but
support team.
it's yeah. No, it's still not working for me. I don't know why.
Yeah.
That's why date was extended.
Even I like refreshed so many times.
no for activity 4, right?
Yeah.
4.
Yes, sir.
Can you
Okay.
check now because in the evening we had a discussion with tech team. They are
Sir,
saying,
sir, I have in activity 1, it's 70 marks, and activity 2 is 30 plus marks. But is display my 0 marks?
0.
Hello. Yes, sir. In
Maybe okay.
activity,
Okay. So have you completed your like number of
activity.
no activities? Okay. So have you completed your reviews for other 3 person?
Yes, sir.
Okay, we'll check. No worries, no worries. So we'll check the.
Sir,
Okay,
in
so
week
that
button working?
2, I'm not completed,
button
but
is working,
week
I
1
think.
completed.
Yeah, working,
Yes, sir,
working.
it is working.
Okay, yeah. Okay. So see, OPP is for online programming exams. That's not for you. Okay, so this is for when you have programming exams. Let's say if you you have taken Python and all. MLP, DBMS. For those courses, you will be having OPP. So, what are the courses you have taken? Accordingly, check the grading document. What are the things you have to do? Okay. So, do not worry about if you have taken only semester one courses of the like this stats one, maths one, English one, and so for these courses there is no OPP. Okay. So you can simply check. It is clearly mentioned for which courses there is OPP inside your grading document. So let me start the week 12 content. Okay, so most of you haven't covered the week 12 content. I will quickly go through. Basically, I will give you. Basically, I'm going to summarize the week 12 content. Okay, so okay, so
Prashant, sir.
yes,
Just like in quiz 2, we got the formula sheet in exam. Are we going to get in this term?
yeah, and term will give. Will also you will get the formula set.
Okay.
Okay, so let me show you the formula sheet. Okay, maybe that will give you some idea what kind of formulas you will get.
Hello, sir? What's the number of week activity? Week activity?
What do you mean by weekly activity?
Week 1 activity.
Uh,
Sir,
okay, I
I
think
have
these kind of
certain.
thing maybe see it simply means you didn't check the grading documents. There is total 4 activities. Okay,
Yes, sir.
so yeah, that's all. There are 4 activities.
नो सर, कितना नंबर कितना मिलता है उसमें और फायदा?
5 marks, 5 extra marks.
ऑल में कि एक में भी?
No, overall.
ओवरऑल। ओके। क्योंकि मेरा वीक 3 जो था ना सर, मेरे मतलब क्या बताए, मेरा बना लिया था, लास्ट में 12:01 अपलोड करने का, तो अपलोड ही नहीं हुआ, उससे पहले अपलोड ही नहीं हो रहा था, हमें 11 बजे से लगे पड़ता, अपलोड नहीं हो रहा था।
Okay, that is something
Sir,
not
I
an
have
issue.
some doubts in some
So,
questions. Can I ask it right now?
from which question? So this is the formula file. Accordingly, you can prepare this formula. You will get in your QP along with your question paper. So you'll get this sample mean, population mean, variance, and all covariance, and these formulas and all. Maybe you have seen in quiz 2 also, right? Bayes
Yes
theorem
sir.
and all.
Yes, sir.
And for
Yes sir.
discrete random variable, there will be formula for PMF
Yes sir.
expectation and all.
Population variance and all.
Okay, so if you suppose you forgot what is the PMF of Poisson, then you can refer this one. Okay, and similarly for continuous distribution. Okay, so this formula
Okay.
sheet you can maybe that will give you clear idea. So there is
So will you share this sheet with us?
we'll upload on the portal along with
Okay,
the
sir.
mock. Okay, so let me start the content. I'm going to discuss the week 12 content. Okay,
Sir,
so
hello,
uh,
sorry for
uh,
disturbing you, sir.
Sir, voice is
Sir,
low, sir.
sir, where is your सर मैं मतलब क्वेश्चन लगाना है हमको, सर क्वेश्चन बहुत डर लगता है हमें, सॉल्व
see,
सेशन नहीं है क्या?
Sir, I
no,
have
no,
sent a question, sir. Sir, I have sent a question to you, sir.
this is PYQ.
Yes, sir. Actually, I'm not
Yeah, okay.
getting, especially the option B, sir. So can you
Okay, so
just
we
explain this?
can we discuss at the end of the session? Okay, because we have to cover the week 12 content. Oh, I
Yes,
think
please
yeah,
start this.
yeah.
All right, sir. Can I ask
Or
at the
else
last, sir?
you can ask, or else there will be at least two sessions related to PYQ, which will be conducted by TS. You can simply ask. That's not a problem. Okay.
All right, sir. Thank you, sir.
Okay. Yeah. Thanks. Okay. So till week 11, like you have seen about discrete random variable and some distributions associated with this discrete random variable, right? What were those? Bernoulli, right? From Bernoulli to we moved on binomial, right? Then after binomial we moved on hypergeometric, correct? And then we saw what is the Poisson distribution. Also one more discrete distribution we saw in week 10, that's called discrete uniform distribution. So all of you can remember what is the relationship between these two and these two and these two and these two? Anyone can comment what is the relation between these two, binomial and hypergeometric?
In binomial, we should take the trials as independent, but in the hypergeometric, the trials need not be independent.
Okay,
Binomial is
that's
just 0 and 1, right? Success and failure means.
it's a Bernoulli.
Yeah.
N times Bernoulli is
Not.
binomial.
Okay. Also, so I'm asking the relation between these two. That's the scenario.
When in
Sir,
hypergeometry, when
sir, in
n
binomial,
becomes large,
Correct. This population size too much large with sample size, right? Then
yeah,
this
then
yes, sir.
binomial, correct? Then
yeah,
binomial will approximate to hypergeometry. What about this binomial to Poisson?
uh, Poisson, like
When the
when
sample size,
n becomes large,
when the
then
sample
N
is
is very
very large,
large and P is
very
small.
small,
small.
Okay.
then it
And
tends
value
to
of
Poisson.
NP will be lambda, which should be finite, right?
Yeah, yeah.
Okay. That's those things we have seen. Now we will move to continuous part. Okay. So let me just do a quick recap about what is a continuous random variable actually. So continuous random variable is nothing but you can simply think when your outcomes of any random event, right? Those are first of all it should be numerical and you can't count, right? It cannot be counted and it's infinitely divisible. Means whenever you will draw a real number line, it will form a interval, right? Yes or no? In case of discrete random variable, if you see real number line, it will take distinct value, right? This value, and this value, for example. While in case of continuous, along with the real number line, it will form an interval. So it can take any value between this interval. Would you agree with me? So in case of
Yes, sir.
continuous variable,
Yes, sir.
I cannot count, right? And second thing is the measurable. Okay, maybe you can recall continuous when we are moving to the continuous world. When suppose this measurable, I'm not able to count. So can you tell me, if I have large number of observations, I should move to the continuous, or would you still proceed with discrete?
No, still discrete. Unless and until
Continuous.
it is countable, even though it is infinite, it is discrete.
Okay, for example, I'm saying you have to toss a coin 1,000 times, and I ask what is the probability x will be less or equal to 949. Then
Discrete.
that's discrete. Will you try to move to the continuous part or not?
Yes, sir.
All right, are you getting my point? So actually, thing is that when you have large number of errors, right, so it's good to go with the continuous. Means you are okay with some sort of error, because it will. Okay, so what I'm trying to say, if you will have a discrete random variable, so what kind of CDF will look like? Something like this. Suppose this is the 0. Suppose this is the 1. This will
Step
be
function type.
it will be something like this. Your CDF will look like this. Yes or
Step
no?
function.
Right.
Yes.
So if I will ask what is the probability, let's say this at 2, then you will simply tell me this jump, right? This jump will give you the probability at x equal to 2 or not,
Yes, sir.
right? So
Sir, why? Sir, why?
why?
समझ में नहीं आप लास्ट में क्या बोल रहे
See, this, if I will ask, suppose this is the 2, I will ask what is the probability at x equal to 2, then you have to tell me the value of this jump. Okay.
Yes, sir.
Okay. So in case
Okay,
of
sir.
continuous, what happens? You will get the graph of CDF like this. It's continuous part. Okay. So it's actually you will get continuous thing. So you can't calculate the jump, right? Suppose this,
Yes,
this
sir.
is 3. For example, I will ask what is probability x equal to 3? It's a 0. Yes or no? Okay. So okay, let me tell you. Let me start. I mean, after a minute, after few minutes, it will be clear. So in case of discrete, what we were like discussing, if x is a discrete random variable, then there is a probability mass function, right?
Yes, sir.
Okay. Mass function means you are interested in if x is taking some values, let's say x1, x2, xn, then what is the probability associated with each values, right? Basically, you can say what is the weightage, something. Yes or no?
Yes, sir.
If now, if I'm saying if x is the continuous random variable, right? So instead of probability mass function, I'm interested in probability density function. Okay.
Yes, sir.
Okay. So short form is PDF. Anyone of can tell me what is the meaning of density?
Mass per volume.
Mass per volume, right? Now,
Yes, sir.
actually, so thing is, now normally probability density function we are denoting as a small f of x. So thing is that let me draw a graph. Okay. Suppose I'm saying, so how it will look like actually? Yes. Second. Okay. Suppose this is x, and this is f of x, and this f of x is any kind of continuous function, something like this, for example. Okay. Now suppose my question is, so what your x will look like? Suppose I'm saying, suppose I'm interested in what is the probability that my random variable will take value between a and b. Okay. Then how I will calculate? Suppose this is the point a, this is the point b. Okay. Then how will you proceed? Any idea? Means I'm interested to know what is the probability that my x will lie between a and b, and this is your function, this curve. Okay.
Area under A
You
and
need
B.
to get the area of the curve.
Any of the
Some
Okay. Basically, what you have to do?
Integrate
do-
over
area
A to
under
B.
sir A to B sir.
definite
Area
integration.
under P
That's
sir.
okay. Actually, what is the integration? Integration is nothing but continuous summation. Yes or no?
Yeah.
Yes
Yes.
sir.
Basically, what you have to do? You have to add all this part. Yes or no? Continuous summation. Yes or no?
Yes sir.
Yes.
This all stress and gap between these two and all. Yes or no? Would you agree with me? You can assume this gap as a delta x. Okay.
Yeah.
So how I can compute this area? Since this is a continuous random variable, continuous density. So I will calculate this as a to
Integration.
b f of x dx. Okay.
Sir, the f of x you have written in the graph is p of x, sir,
This is?
in the y-axis.
Yeah, this is f of x. Yeah. Basically, you have to integrate this function, okay, to get the probability that your random variable will lie between these two value. Okay.
Okay, sir.
In case of discrete, what was the two basic properties to be a valid PDF? Sorry, PMF.
Greater than 0.
Probability should be equal
Sir,
Yeah,
to
probability
Sir.
of each exercise should be between 0
Zero
and
and
1, and
The between,
summation of
yeah.
all the
One.
probabilities should be equal to 1. Correct. Now we have continuous. So first of all, I will say this probability should be between 0 and 1, right?
yes sir.
Okay. Not equal to. Okay. No one corrected me. See, if we are taking equal to, it will be discrete. Okay. So I will say x lying between A and B. Yes or no? In a range, right? In an interval. In case of
Yes, sir.
continuous, you can't talk about a single point, right? Because at a single point, probability will be 0. Okay. I will show you how in a minute. So thing is that I will say probability that this will be between 0 and 1. Since we have to do okay. So in case of the continuous distribution, integration over the range, okay, it will be 1.
1.
Would you agree with me?
Yes
So
sir.
basically,
Yes, sir.
integration is nothing but you can say this is the continuous summation.
Integration. Yes.
All
So
right.
it is from R to upper
It's
limit.
a R means whatever the region. I'm just I have written in general actually. Basically, thing is
range
that
of-
Minus infinity
Okay,
to plus
okay.
infinity.
yeah. So it means suppose this is your f of x, right? So this is suppose this is total area. Then suppose this is total area. It can be anything, right? So I have written just a R just for simplicity. It can be anything. Okay. So area under the curve. So thing is that this means you can treat as a. I mean you can say area under the curve is 1 actually. All right. Some sort of idea you are
Yes, sir.
getting or not? Okay. Now.
Yes.
So in case of continuous thing, suppose I'm saying probability A, okay, suppose this is the case, you can simply tell me A to B f of x dx, right? What if
Yes.
I will write probability A less than x less than A?
It will be 0.
0.
A to A f of x dx, it will be 0 or not?
Yes,
Yeah.
sir. 0.
Yes, sir. 0.
Background noise. So can I say probability at a single point, if I will ask probability at x equal to A, it will be 0?
Yeah.
You can think like this. Whenever you will draw a CDF graph, right? Suppose CDF graph is something like this. Suppose this is the 1, this is the 0, for example, this is the capital Fx. So in case of discrete, you are getting the CDF graph something like this, right? Means basic jump, right?
Yes, sir.
Whenever I will ask the probability, let's say this is 4, you will say, you will subtract, I mean, basically you will tell me the value of this jump. But if I will ask, suppose this is the 4, I will ask what is the probability that x equal to 4. Will you able to tell me the jump here?
No, sir.
No.
No, right? So this
No,
will be
sir.
0.
No, sir.
Yes or no?
Yeah.
Yes,
So
sir.
Yes.
Yes, sir.
case of continuous distribution, whenever there is something, it is asking probability at a singleton point, it will be 0. Would you agree with me?
Yes.
Now, since probability at a single point is 0, can I say probability A less than equal to x less than equal to b? This is same as probability A less or equal to x less than b. Yes or no?
Yes sir.
Can I say
Yes,
this
sir.
probability A less than x less than b?
All the same.
Yes, sir.
Probability A
Also.
less than X less than B.
Yes, sir, same.
Yes, sir.
Right? All are same. Great. Okay. Now, something we have seen called CDF, right? Cumulative
Distribution
distribution,
function.
right? In case of discrete. So what we were doing in case of discrete, if I will ask what is the f of A, what you had to do, probability X less or equal to A, right? In case of discrete random variable, what we were doing, we had to accumulate, we had to add all the probabilities till A. Yes or no?
Yes, sir.
In the case
Yes,
of
sir.
continuous, what I can do? I have to integrate the like
Fx dx.
function fx dx from minus
Minus
infinity to
infinity
A.
to plus infinity.
No, not
Up to
plus
A.
infinity. Up
Oh,
to A
A.
only, right? I'm interested till A
so yeah,
only,
yeah.
right? So minus infinity means I'm talking about the what is the lower limit of your X. Okay.
Yes, sir.
All right. So in the case, suppose this, okay, suppose you have been asked what is the probability X less than A. This is same as probability X less or equal to A in case of continuous only. In case of discrete, the meaning these two will different. Yes or no?
Yes, sir.
Yes, sir.
Yes.
So this is same as minus. So basically what is happening here, probability X less than A, I'm saying probability, suppose I'm saying probability X less or equal to A. So this means what? I can write probability X less than A plus probability X equal to A or not,
Yes, sir.
right?
Yes, sir.
In
Yes,
this
sir.
case, how you can calculate this probability? Lower limit to this
A
point fx
Fx
dx
dx
and probability at a single
Plus
point will
0.
be
0.
0.
0.
Okay. So what if this is happening? Suppose this is your CDF graph. I've been asked what is the, let's say, okay, suppose this is your PDF graph. For example, my question is this is suppose A, and I ask what is the probability X less than X is less than A, right? So basically what you have to do, you have to integrate the area from this lower limit to this part. Yes or
A.
no?
Yes.
This curve can be anything. It can be something like this. Yeah, it can take. That's why I have written minus infinity means lower limit. I'm talking about. Okay. Suppose I ask what is the A. Suppose A is there, and what is the f of X less than A. Then you have to integrate all this region. Yes or no?
Yes, sir.
Yes, sir.
Okay. Some rough idea you are getting or not? Okay.
Yes, sir.
So another thing is we discuss about expectation of a random variable in case of discrete. So what we were
Excuse
doing?
me, sir. Before
Yes.
we talk about expectation,
Mhm.
like suppose there is a graph which comes under which goes in the negative y-axis. Suppose then
Okay.
is it so? Is it when we are calculating the the probability?
Mhm.
Is it permissible to like take the mod of the function?
See, thing is that first of all, probability, yeah, correct. Probability cannot be your negative. If it's negative, then there is something wrong. Okay. First thing.
All right.
Second thing, if I'm talking about any modulus function or any positive function and all, actually, in stats 2, we are going to study about, function of random variable. So there is something called monotonic function. Basically, we are talking about positive region or I mean, you can define. Suppose I'm interested in mod of x, x square
Yeah,
or
yeah.
x cube, something like that. So those it will come later. Okay. As of now, we
Okay,
are
okay,
just
okay.
creating the. We are going to discuss the foundation of this continuous. We are
Okay,
just.
okay, okay, okay. All right.
So in case of a discrete, how we were calculating the expectation? Summation of x into probability of x equal to x into not dx. Sorry. This is the something we were calculating expectation of x, right? This is for when x
Yes.
is discrete, right? If x is continuous, then what will be expectation of x? So this integration you can replace with, sorry, this summation you can replace with integration sign, yes or no? Because we have to do continuation summation, right? X and this probability will replace fx dx.
Yes.
Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Same thing, if you have to calculate the variance of x, then I can calculate expectation of x square, expectation of x whole square,
Yes, sir.
Yes, sir.
right? Now, for this, how I can calculate expectation of x square? Integration this x square into fx dx. Yes or no?
Yes, sir.
So far, some idea is clear.
Yes, sir. We are replacing
Yes.
summation with the integration.
Integration. Basically, what we have to do, we have to do continuous summation. So continuous summation is nothing but in mathematics we are saying it's a integration. Okay.
Sir, one
So
small doubt, sir.
mm,
We are integrating a function, right, sir? That
mm.
function is PDF function or CDF of the continuous function, sir?
Can you come up again?
We are integrating a function to find the area now, sir.
Yes.
That function f of x is the probability density function or it's a
Yes.
cumulative distributive function,
No,
sir?
it's a probability density function. See, CDF is
Okay.
different thing, right? CDF means I'm talking about probability till a point, right? So in this
Yes, sir.
case, to get a probability till a point, you have to integrate your probability, let's say minus infinity to that point. Okay, this is called CDF. So CDF means you have to you are accumulating the probabilities till that particular point. Okay.
Okay, sir.
All right. Yeah.
Yeah.
So now so we will see some like in case of discrete, we saw some different scenarios, some discrete distributions, right? We saw the
Case of a continuous one, sir, that ex square minus fx square also it should write, right?
no, it's not okay. Tell me, what about expectation of x square in case of discrete? How will you do? Summation of square of each values and then probability,
Simply multiply probability.
right?
Yes. Yeah.
The similar thing now, can you relate?
Okay.
Yes.
Okay.
Okay. Yeah. So we saw some discrete distributions, for Bernoulli. We saw whenever you had two outcomes only, if you are doing any experiment, then we saw it's, it was Bernoulli. Then we move on, like sum of n IIT Bernoulli random trial will constitute, I mean, basically will combinedly, it will give you the form of binomial distribution, right? Now in binomial distribution, we saw like we were interested in number of success in an independent trials. Okay, in an independent Bernoulli trials. Then we moved on hypergeometry. There was some different scenario for hypergeometry. Then we saw Poisson distribution. Now in case of continuous random variable, so first distribution is very simplest one, which is called uniform distribution. Okay. So what is this actually? Suppose I'm saying, let me write a continuous random variable has a uniform distribution if, or normally we are denoting this, okay, I will denote this as a x follows uniform a comma b. Okay, suppose this is two things. Okay. So I will show you the how pd like how we are getting the pdf of this. Okay. Suppose what is the meaning of this uniform distribution? Suppose this is your x and this is your x. Okay. So yes, Vishwaji.
Sir, before going to uniform distribution, sir, what would be the mean of that continuous random variable? I mean, minus infinity to the particular, for example, a, sir, minus infinity to a, and x of fx dx.
Yeah, this one.
Would it be, sir, the mean, sir?
This one mean.
Yeah, mean of that continuous. What would be the mean?
No. This is not a mean. Mean is this one.
Okay.
Okay. Basically, you can think, if you want to just memorize in your memory how we are calculating in case of discrete summation of x into px, right? If x is discrete, right? If x is continuous, this summation you can replace with the integration part. That's all. And this will be replaced by the PDF. This is the probability mass function. This will denote the probability density function. All right.
Yes, sir.
Okay.
So here we ask for hello. So CDF we asked, right? CDF for cumulative distributive function and PDF. What's the difference between that in continuous? So both are looking like similar. Minus infinity to if you are integrating minus infinity to x fx dx for a CDF and PDF are same, right?
No, PDF is the different thing, right? CDF is something you okay. Let me tell you. Suppose this is your f of x, for example. Okay, this is your x. Okay.
Okay.
Suppose this is fx is any kind of function you have, this kind of function, and I will ask what is the f of a, capital F of a. Okay. So this means I'm interested. What is the probability x less than or equal to a?
Okay.
This is the definition of CDF. So what if x is a continuous random variable, right? So how I can calculate the probability x less than or equal to a? Suppose this is your a. In case of continuous, how I can suppose this is the discrete, then you will simply add all the probability.
Yes, sir.
Right? Okay. But in this case of continuous, how you can calculate this probability? Basically, you have to integrate what? This PDF, this function. Are you getting?
Basically,
Probability distribution function.
Yeah, basically the CDF is a probability that random variable, values less than or equal to x, whereas this PDF is a probability that a random variable, say like for example x, will take a value exactly equals to that x particularly.
Basically, PDF, see density. See what? Okay, can you tell me what is the idea behind probability mass function? It shows probabilistic behavior of your discrete random variable, right? Whatever the possible values your x is taking, right? Now, if x is the continuous, it's not a discrete. So I'm interested rather than mass, I'm interested in mass by volume, right? Which is called as a density.
Yes, sir.
Right. So in case of, okay, let me take a little bit different example. Not a different example. Let me try to, okay. Suppose I'm saying x is taking only x1, x2, x3. Okay. If I will ask what is the f of x2, then what you will do? You will add probability at x equal to x1 plus probability at equals to x2.
Yes.
This is nothing but probability x less than or equal to x2, right?
X2, yes.
When this is the discrete. Okay. Now, if I'm saying this is, suppose x is a continuous, and rather than instead of a, let's take this is x2. There is one of the value x2. Okay. My question is, what is the f of x2? This means probability x less than or equal to x2.
Yes.
Since it's the
From the
continuous,
minus infinity to
yeah. So it's
x.
a continuous. I have to do continuous summation. Continuous summation means it's an integration part. See here what you are doing, you are adding the probability, right? Now here I will integrate this density
function
from lower limit to till this point. Clear?
Till the value whatever the given.
Whatever the given. All right.
So the thing is like what is the PDF here? What is PDF means between any two
PDF
intervals.
We have lower limit in PDF. Right?
What was the role of PMF?
So at that point, what is the x value takes?
See, probability, yeah, basically probabilistic behavior. Right? So I can say probability distribution of your random variable x. Can I say?
Sir.
Yes,
okay.
yes.
The same thing for continuous. Means probability distribution curve of your continuous random variable is same as probability density function. Okay?
Okay.
Yeah.
Can you give example for that?
It can be anything, right? So you can take x square. Okay. Suppose x is a length of something. Okay. Length of a square, or length of or very specific if you want. Let's say suppose what you can do. Let's say I'm like amount of time to wait at a particular bus stand or something like that. Waiting time and all. Okay, so waiting time is what? Can you do as a discrete or continuous?
It is a continuous.
Continuous.
Yes.
Okay.
Time is comes under continuous. Yes.
Yeah. Right. So
yes.
Similarly, you can. So basically, your graph. It will depend on the curve of your graph. For example, it can be anything. So if you want to
Can we
specify,
consider fx is equal to x?
fx is equal to
X.
no,
Like
you will get 0 then.
okay.
See, means what you are saying, fx equal to x means you are talking about probability at a single point, right?
Oh yeah. Okay.
I think
Yes.
he's saying the function fx is x. That is the straight line.
Yeah, that is the straight.
Yeah.
You can think. Let me take. Okay, let me take something like this. Maybe if you are not. Suppose a PM. Sorry, not PMF. Probability mass function, I should say actually. Suppose there is electric cable, something like, okay, if you have electric cable and all, I can define my random variable x as a, let's say, diameter of that electric cable, okay, and my function is something like this. Suppose it can be anything. Let's say I'm saying some c times x 1 minus x, okay, for example, and this x
Okay,
lies
sir.
between 0 to 1, okay. So what will be the curve of this? So this fx is now, this is the something probability distribution of your random variable x.
Yes,
Are you getting?
correct.
So thing is that x is nothing but so this fx, what it will denote, it will be, suppose this is f of x, for example, okay, this is your function basically, okay, this is giving you information about continuous random variable x, what kind of curve it will be. Okay, this curve will be like this curve can be like this curve can be like this, anything. This is same as this will be known as f of x. This curve can be like this also. This curve can be symmetric. This is f of x. So this is nothing
Sir,
but it is giving you like a probability distribution curve of your continuous random variable. Okay, if I'm interested in that particular region, what is the probability that x will be from a to b, what you have to do, you have to integrate the, basically you have to find the area from a to b. If I will ask what is the probability a less than x less than b, I have to do I have to integrate a to b, that particular pdf. It can be anything. It can be this cx c is the constant. Let's say I'm taking 6x 1 minus 6. So what you have to do, you have to integrate this pdf 6x 1 minus x dx. Okay, it can be x cube 1 minus x, something like anything. Okay.
Yeah.
So now
Understood. Thank you.
yeah, some sort of idea. So this is the probability density
Density
sir,
function.
Okay.
can you draw the graph for capital F of x, sir?
Actually, capital F of x, it will depend, right? So capital F of x, first of all, it will always be lie between 0 and 1. Okay. For different kind of scenario, it will vary. Okay. I will draw for this continuous and other distribution which we are going to see. Okay. I will draw. Do not
Okay,
worry.
sir.
Okay. Yeah. So thing is that, so what is the continuous uniform distribution? So what is the meaning of this? So suppose you have a point A to B. So it will take, so as name suggests, uniform, right? So it will take a single value only, which is K. Okay. So this K is nothing but from here to here. Okay. So thing is that how you will calculate the value of K. So what is the function here? Okay. What should I write f of x here? Any idea?
Straight line, it's a constant.
It's a
Constant K.
That's okay. That's constant K, right?
Yeah.
Only then I will say this is the uniform distribution.
Yes,
Thing
sir.
is that how I can calculate the value of K. Okay. So I'm going to use
The
the
area should
property
be
of
equal to 1.
correct. So area under the curve, what is the area? A to B, f of x dx, this should be equal to 1.
Yes, sir.
Yes or no?
Yes.
So those who do not, those who are not familiar with the integration, do not worry. Just be, ready with this formula and all. There will not, the questions will be framed in your quizzes such that you can do without integration with the help of CDF only. Okay. One more thing I have informed in the beginning of the session. This is the formula sheet you will get for your end-term exam, like this mean and all, variance and all. This formula, this like permutation combination you have seen in quiz 2, it will be there. And this formula sheet also, all discrete distributions along with their PMF, expectation and variances. So if you forgot any mean variance during your examination, do not worry, it will be there. And this part also, right? Uniform, exponential, what is the mean of expectation of the uniform, variance and all for uniform exponential. It will be there.
Are you
okay?
sure that the formulas will be given?
Yeah, I have given myself, so do not worry. I'm sure.
I'm not
So
given to go to static 2 and so in.
So if you okay, so these are formulas, it will be there. Okay.
So what about the Z table?
Okay, so one more thing regarding G table. So there is like it will maybe beneficial for you. So there is only one question from normal distribution, which is I think MCQ or MSQ of which carries only 2 marks. Okay. Accordingly, you can prepare for your normal distribution, but there will be weightage from other topics. One more thing, this question you can do with, I mean, for this only lecture video or activity is more than enough. This is very concept basis based question.
So better you could have provide that particular the Z value, so that the particular Z value if I provide it would be better. No need to have a entire table.
No. So there is not any question for which G table is needed. I mean, G value is needed. Okay, no need to worry.
Okay.
All the required things will be given to you. Okay, if it is necessary, it will be provided. Okay.
Sure.
Okay.
Thank you, sir.
Yeah. Let's see. So this is A to B. This is K dx 1. Okay. So K I can take outside. It will be A to B. 1 into dx. This is equal to 1. If I will integrate this, I will get x, right? And A to B. Okay. Now what I will get here, I have to substitute this upper limit B minus A equal to 1. So K is what? 1 upon B minus A.
Yes.
Right? K is 1
Right,
upon
sir.
B minus A or not, right? So basically, what is the PDF of uniform distribution? F of x is f of x as 1 upon B minus A. Okay. So I can say if x follows uniform distribution with parameter A and B, then my PDF will be 1 upon B minus 7. X is lies between A and B, and it will be it will take value 0 otherwise. Okay, otherwise it will take value 0. All right.
So this will be a probability density.
Yeah,
No,
this is
this is
the
a probability density function of a uniform random variable.
uniform distribution.
Yeah, uniform. Okay.
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 Now there is something called standard uniform. Okay. So this is there is a scenario for this standard uniform distribution. So what is the scenario when this A is 0 and B is 1? Okay. So this is known as standard uniform distribution. So if I will say x follows uniform 0, 1, then what will be f of x here? Here it will be 1 only.
Yes.
Right?
Yes, sir.
Otherwise, OW means otherwise. Okay. So this is just idea behind this. Now let's come to the f of x. Right. So if I will ask cumulative distribution function CDF of uniform distribution. Okay. So what is the CDF basically? Capital F of x. How I can calculate probability x less or equal to x?
Yes, sir.
Yes.
Right. So what is the meaning of this x less or equal to x? Basically, what I have to do, I have to integrate. So here I'm saying x follows uniform A to B, right? Then what is the f of x? Small f x is will denote your PDF. It will be 1 upon B minus A, and x will lie between A to B. So what I have to do? I have to integrate the PDF from where to where? A to small x.
Yes, sir.
Yes or no?
Yes,
Okay,
sir.
this means what? This is your A, this is your B, and this is your region. I'm interested. What is the f of x? I'm interested. What is the probability for this region? So what I have to do? I will integrate the PDF from A to x.
Yes, sir.
Yes or no?
Yeah.
Right?
Yes, sir.
This is the continuous. Now for this, what we have to do? So what is the f of x here? 1 upon
1 upon b minus a
dx, right?
dx.
1 upon b minus a I can take outside or not?
Yeah, outside is for constant.
Now, what it
Sir?
will be 1 upon b minus a, and this will be x, and this will be a to x. And if I will substitute this value, it will be x minus a divided by b minus a. So what is the CDF of your, uniform distribution is nothing but, x minus a divided by b minus a. Yes, no? Is
Yes,
this
sir.
clear?
Sir, I have
Yes?
a doubt.
Yeah.
Sir, what will be the weightage of these 3 months in our September exam?
Weightage for?
What will be the weightage for like quiz 1 syllabus, quiz 2 syllabus, and this
It is given in mail.
Yeah.
Just check the mail.
I haven't received it yet.
Can't say you haven't received because I myself send the mail. It's for everyone. Okay. So just
2030,
check it.
Check the
2030.
mail. Check the mail.
Okay, sir, I'll check
Yeah.
right now.
Yeah. Yeah. Okay. So this is the CDF of, so where it is actually where you can find this as a helpful. Okay, before I'm giving an example, let me tell you the expectation and variance. So I'm not going to do the derivation part, right? Expectation of x, how I can calculate? Integration of x into fx dx, right? Right. So what is the limit? I have to integrate a to b. Yes or no? Because I'm saying x follows uniform distribution, a to b. So basically what it will be, a to b x, and what is the PDF? 1 upon b minus a, right?
Right.
Yes or no? So
Yes.
I can take 1 upon b minus a outside a to b x dx. If you will integrate this part, you will get 1 upon b minus a x dx. It will be x square by
X square by
2
2.
a to b, right?
Yes,
Well,
sir.
Right.
anyway, I have done maybe. So it's a 2 b minus a. Numerator part will be b square minus a square. So what you will get? I can write b minus a, b plus a divided by 2
Yeah.
b minus a, right? Numerator part a square minus b square. So this will get cancelled out. So I will get a plus b divided by 2. So this is the expectation of x when x is uniform distribution. So you can see this one. Okay, you can cross check with this. So this is the C,
Yes. Yes.
right? Expectation of x, right? And this is the CDF, right? X minus a divided by b minus a. Correct? Okay. So this is the variance formula. I'm not going to the derivation part actually. So you can calculate, you can find the expectation of x square first, then you can subtract this a plus b divided by 2 whole square, you will get the variance. So variance of, uniform distribution is nothing but b minus a whole square divided by 12. Okay. So these 3 to 4 formula, if it's in your mind, that will be very helpful for you. If it's not, you can prefer the formula sheet. Okay. So I'm going to take some example and we'll do a
Can I please show
questions.
the calculation part? Just 1 second.
Which calculation part?
Of the variation, yeah.
This is for expectation I did.
Okay, yeah, for expectation. Yes.
Okay. For expectation of x I did.
Yeah,
Okay?
1 second.
So same thing, if you want to calculate expectation of x square, it will be integration of x square fx dx. Okay. And this now it will become x cube divided by 3. Okay.
Yeah, sure. Thank you.
Yeah. All right. So let me take some examples. Maybe that will give you the idea behind, uniform distribution. So let me take one example. Suppose something. Yeah. Okay. Let me write that. Suppose there is one example that, okay, by using this kind of questions, right, you can do the question without integration actually. Without without integration.
Voice.
Okay, now it's fine.
Yes, sir. Fine.
Yes, sir.
Clear, sir.
Yeah.
Clear.
Okay.
Yes, it's continuously fluctuating, sir. Slow, high, low, high.
Oh, is it? So please okay, do let me know whenever you are finding. So when you can use this kind of, uniform distribution, suppose I'm saying a bus arrives at a bus stop, okay, every 20 minutes, for example. Suppose if you arrive at the bus stop let's say at a random time, suppose what is the question, suppose question is what is the probability, okay, what is the probability that you will have to wait, I'm saying less than 5 minutes for the bus. A question is clear to all of you?
Yes, sir.
Okay. So now if your x is, you can define as waiting time for bus. So can I say axis follows uniform distribution from 0 minute to 20 minutes? Would you agree with me?
Yes, sir.
Yes.
Right?
Yes.
Right? This is your A, this is your B.
B.
Now question is what is the probability that you have to wait less than 5 minutes? That means I'm saying x less than 5.
Yeah.
Yes or no?
Yes.
Yes, sir. It's
Correct.
-5.
So just a few seconds before we discuss, okay, there is two things. If you have to calculate this part, first is you have to integrate 0 to 5
It's okay.
f of x dx. So first of all, what will be the f of x here? 1 upon b minus a, that is 1 upon 20 minus 0, which is 1 upon.
Yes.
Yeah.
Yes or no? That is the PDF of uniform distribution. So first approach is you can integrate, or is what you can think here. So what was the CDF of uniform distribution f of a, f of x, probability x less or equal to x? It was x minus a divided by b minus a. Yes or no?
Yes, sir.
Since this is the continuous distribution, this probability x less or equal to x, can I write this is the probability x less than x? Yeah, equality, right? So probability at a single point, it will be 0. Right? So what is the question here? Question is probability x less than 5. So what is the value of small x? Small x is 5
5, sir.
minus. What is the A?
0.
0.
What is the B?
20.
What
Minus
is the
0.
A? So 5 by 20 will give you answer.
1 by 4.
2,
Yes or no?
Yes, sir.
Now, suppose I ask what is the probability you have to wait for at least 5 minutes. So what should I write?
Greater than.
X
Greater
is
than
greater
than
than
equal
5.
Equals to 5.
At least 5 minutes, right?
X
So
is
that
greater
means
than 5.
x is greater
X is
than or
greater
equal
than
to
equals
5.
5. Yeah.
No, so there is two approach. First is you can integrate from 5 to 20, that
20.
PDF, or else if you don't know the integration, that's okay. So can you tell me this probability x greater or equal to 5? Can I write this as a 1 minus probability x less than 5?
Yes, sir.
Yes, sir.
All right. Now for this particular part, probability x less than 5, can I apply the CDF formula of uniform distribution?
Yes, sir.
Yes.
We can.
Okay. Now, if you don't know the integration, even though you can do it. Yes or no?
Yes.
Yes, sir.
Correct? Would you agree with? So this probability x less than 5 we have calculated, right? This 1 by 4. So you can simply calculate this x less than 5 and you can simply subtract 1 minus 1 by 4. This will give you the 3 by 4. Is this fine?
Yes,
You're
sir.
fine.
Okay. Now, everyone has pen and paper right
Excuse
now?
me, sir.
Yes.
I clear whole the concept and whole the question, but in this question,
Hmm.
how we can know that this is the question of uniform distribution?
Okay, that's what. Okay, sometimes what we are doing, we are clearly mentioning like this is follow uniform distribution. But here, what is the case here? Can you think a bit? A bus arrive at a bus stop every 20 minutes, right? So I'm
Yes, sir.
interested in it's a continuous, right?
Yeah, this
Okay,
is
so
clear. This is continuous.
yeah, so thing is that whenever you will do some more and more question, it will be clear. Let me give you some examples, some different kind of example. Maybe that will give you the idea. Okay, suppose I'm saying everyone has pen and paper.
Yes, sir.
Okay, suppose I'm saying a factory produces metal sheets, let's say with thickness. Okay, and what is this whole thing? Suppose I'm saying this is uniformly distributed, between this thickness part, uniformly distributed, let's say between 4 mm and 6 mm. All right, suppose my question is, what is the probability uh, probability that let's say I'm saying, what is the probability that a randomly selected seed, okay, will have a thickness let's say between 4.5 mm and 5.5 mm. Okay, first of all, tell me what is the x here. X follows uniform distribution meters.
4 to
4,
6.
6.
4 to 6. This is your A, this is your B, right?
Yes, sir.
So at the same time, what will be the f of x? 1 upon
1 by
B
2.
minus
B
A.
minus A.
So 1 upon 6 minus 4, which is
2.
1 by 2.
Now,
Z-
this is the
0.5.
case. So what is the question? Probability x lies between 4.5 to 5.5, right? This is the question. Okay.
Yes,
So there
sir.
is two approach. One approach is you can integrate the PDF from 4.5 to 5.5,
Yes, sir.
right? Because I'm interested. So thing is that this is the case of, suppose this is 4 mm, this is a 5 mm. I'm asking what is the probability that, suppose this is 4.5, this is the sorry, this is 6, so this is 5.5. So I'm asking this probability. So first is I can integrate this to this as a f of
Yes,
x
sir.
dx. Now another approach is, maybe you have seen, if I will say probability a less than x less than b, can I write this as a probability x less or equal to b minus probability x less or equal to a?
Yes, sir.
That means capital F of B minus
Minus
capital F of
capital
A.
F of A.
This is CDF for this. This is CDF. Would you agree with me?
Yes, sir.
In case of discrete, we have seen, right? So here, what is the case? X lies between 4.5 to 5.5. Can I write probability x less or equal to 5.5 minus probability x less or equal to 4.5?
Yes, sir.
Yes or no?
Yes, sir.
Yes, sir.
Now, is for this particular part, I can use the CDF formula and I can subtract. Yes or no?
Yes, sir.
So what is the CDF formula in case of uniform distribution f of x? This is x minus a divided by b minus a. This is capital F x I'm talking, which is CDF. Okay. So can you tell me what is this? What is the small x here? 5.5
5.5.
minus what is the a? A is
It's
4.
4.
Okay. Divide by b minus a. What was the b? 6.
6
Minus a is
4.
4 minus. For this, what is the a?
1.5.
Sorry, x. 4.5. This is 4. B is 6 minus 4. Okay. So this 5.5 minus
Not coming, sir.
1.5. See, 5.5 minus 4, what it will be?
Yes, 1.5.
So it will be
1.5 by 2.
1.5 divided by 2. And
divided
what
by
is
2.
this? 0.5 divided by 2,
Which is 1 by 2.
which is again 1 by 2.
Yes, sir. 0.5.
So, yeah. So here are you getting the idea? So without integration, I can calculate the probability by using the CDF formula directly.
Yes, sir.
Everyone is getting this part?
Yes, sir. Understood.
Okay. Yeah. Let me
It's a
take
long method.
another example. Maybe that will give you now. So that question you have to do. I'm just creating. Let me see what are the values we can take. Okay. So let's say a task. There is a particular task can take like you have to complete that task. Can take between let's say I'm saying 30 minutes to 90 minutes to complete that particular task actually. Okay. And I mean, let's say depending on the some complexity and all. Again, I'm saying if the time required to complete the task, for example, required to let's say complete the task. Suppose I'm saying this time required to complete the task is, let's say, uniformly distributed. Okay. Now my question is, what is the probability that it will take between, I mean, to complete, let's say I'm saying 45 minutes to 60 minutes. Okay. Question is clear to all of you? Now I'm going to give you some 2 to 3.
Yes, sir.
Excuse me, sir. Sir,
Yes. Your voice is not. You are not audible. What if you are saying something?
Sir, I'm getting 0.2, sir. Is it correct?
Yeah,
1/4, sir.
0.25.
0.2.
Okay, thank you.
0.2 by 1/4.
Yeah.
sir, I have a doubt in 11.3 question number 5. Can you take it now, or you you will take it after the
After the
session?
session.
After the session.
Okay,
Maybe
thanks.
after.
Sir went for break. Wait for some time.
Guys, maths, we have an Excel sheet for all the links. Do we have for stats
We
also?
don't have for stats and CTMs. We don't have.
Stats after we are proposing, then only started recording the session.
Yeah. Hello. Yeah. Okay. So am I audible?
Yeah.
Yes, sir. Audible, sir.
Discussion going on.
No, he was asking about the stats recording sessions of including TAs and other stuff.
It's already recorded. Okay. So what is the X here? Like, so this will follow uniform distribution from 30 minutes to
90
minutes, right? Now, So thing is that, okay, first of all, let's write
PDF
from
is
1 upon b minus a. So
90
b
minus
is,
30.
which is 1 upon
60.
60. So question is, what is the probability that it will lie between 45 to 60?
60.
So this is this part I can write probability x less or equal to 60 minus probability x less or equal to 45.
45.
Now we know this is the PD. Sorry. Okay. So we know what is the probability of x less or equal to x. It is nothing but x minus a
X
divided
minus
by.
A upon B minus A.
Now, so what is the x here? This is
60.
minus a is 30 divided by b minus a 90 minus 30 minus, it will be 45 minus 30 divided by 90 minus.
minus 30.
Now this will be 30 divided by 60 minus 15 divided by 60, which is 15 divided by 60. This is the answer everyone got?
Yeah, sir.
Yes, sir.
Yes, sir.
Yes, sir.
There is a twist. I'm saying tasks will take at least 50 minutes to complete. So that means x greater or equal to 50.
Yeah.
All right. Yes or no? So it,
Yes, sir.
can I write? I can write 1 minus probability x less than 50. 1
Yes, sir.
minus for this particular part, I can compute CDF. So what it will be 50 minus 30 divided by 90 minus 30. Would you agree with me?
Yes, sir.
So it will be 1 minus 20 divided by 60. That is 40 divided by 60. Yes or no? Now suppose I'm saying task, I mean, it will take at most 55 minutes to complete. Then what should I write here? At
X less
most.
than equals.
Suppose this
X less
problem, above
Less
problem
than or
is
equal to
Less than
50.
equal to.
sir.
Sorry?
Above problem is equal to in PDF.
Above problem is what?
PDF.
Huh?
That probability x greater than 50, sir. Same way that integration method, how to do that one?
Yeah, you have to integrate. So for this part, right? So first of all,
Second answer, greater than 50 parts, sir.
okay. So what is the limits for a and b? So for x, it is from 40 to 60, if I'm not wrong.
Yeah.
Yeah, sir.
30 to 90, right?
Yes.
30 to 90.
Okay.
30 to
So
90.
this is asking, it will be more than 50. That means I have to integrate from 50 to
50 to 90.
Okay.
Understood? Okay. So you can
अगर
think
करी
like
जा
this.
मतलब समझी जा,
Suppose
तो
this
तेरे
is.
लिए यूं चंगा होएगा.
I think if you do not have anything, right? So it's good to mute yourself. Okay. So suppose this is 30 to 90. So my question was at least 50. Suppose this is the, 50 somewhat here, for example. So I'm asking greater than equal to this part, right? So I have to integrate from 50 to 90, correct? So for this part, I can directly use the CDF 55 minus 30 divided by 90 minus 30. This will be the answer. Be careful. Suppose I ask, what is the probability that it will take exactly 45 minutes to complete? What will be the value for this?
Zero.
Zero?
Zero.
Yes or no? Because probability at a single point in case of continuous will be
Zero.
Okay. All right.
Zero.
So be careful. If you are able to answer this question, that means you will get some marks in your end. So next is okay. If I will ask, what is the expected time to complete the task? What is the expectation? A plus B divided by 2. So you will write 30 plus 90 divided by 2, which is 45. Okay. Yes, no, clear?
Yes.
Yes, sir.
Yes.
60.
Yes, sir. 60.
Oh, sorry. Yeah, sorry. Thanks. This is the 60. So next is something called, non-uniform and triangular distribution. So that's I'm not going to do in detail. So basically what you have to do in non-uniform and triangular distribution. Suppose you are
Sir,
getting this kind of, once again, this kind
excuse
of
me,
graph.
sir.
Yes.
So before going this, actually, I didn't get that at particular 45 minutes it is 0. Can you explain that?
So what is the probability at a single point?
Yeah, that can you explain it?
1 by
Okay.
6.
See, not 1 by 6. How you
Yeah.
can calculate the 1 by 6?
Sir,
See,
1 by 60.
probability. See, 1 second. Suppose I'm saying in case of continuous, you have to integrate x. So what you have to do? You have to integrate a to b fx dx.
Yeah.
Yes or no?
Yes.
What if I will ask the probability at x equal to a? That means what? You have to integrate a to a
Particular time.
fx
Yeah, yeah,
dx.
0.
It is 0. Now is this fine?
Yeah.
Okay.
Yes, sir. Okay.
So probability at a single point in case of continuous will be 0. Okay.
Okay.
So in case of this non-uniform and triangular, it's like you will get something this kind of graph and all. Then what you have to do? You have to apply the area formula of triangle, which is half into base into height. So this is something you can get. So what you have to do? Basically, you have to apply some area formula and all. So basically, from here, what is suppose we have been asked probability from this point to this point, this will be base, and what is the height? Basically, you have to apply the formula.
And
Okay.
the area is 1, right? Like
Total
area under
area,
that.
total area under the curve is it will be 1.
Total.
Yeah. Okay. So that is something you can see. So next major important is called exponential distribution. Okay.
Sir,
So
can
in
you
which
scroll up, sir? Take
Yeah.
the pics of the this one, non-uniform. Okay. Done.
Okay. So like non-uniform distribution, it can take any kind of graph. Suppose non-uniform is it can take something like this part, and then this kind of graph. Okay, something like that. Then what? Suppose what is the probability from here to here? Then you have to find the area of this rectangle and okay. So this is just
So, sir,
basic
in
formula. You
that
can
case, the formula for area will differ.
yeah, formula of area will differ, right? Area of rectangle, area of triangular. Okay.
Okay.
Okay, but it's a very basic formula. It will be clear via lecture. So I'm just trying to cover the major distribution. So
One
next one
more
is
question, sir. One more question. Will the shape will always be in form of rectangles and triangles only?
okay. How many lectures you have seen as of now?
Sir, till week 11, sir, till week 10, sir, week 11 I have started, right?
Okay, so start week 11. This is I'm discussing week 12. Okay.
Okay, sir.
So there is something called just triangular distribution and non-uniform. So in case of non-uniform, what is sorry, in case of uniform, it will take a single value throughout India, right?
Okay, sir.
In case of non-uniform, it will so area will vary. Let's show you from the portal itself because you haven't seen. So why I'm not going to that part, because it's a very basic thing. You can clear with
Okay,
this
sir,
if
sir,
you still.
leave, sir. I will watch it.
Okay, so this is something I'm trying to say. Okay, so if you have been asked the probability, you can simply calculate yes or no, right? Suppose this is something. What is the probability for a particular part? Then what you have to do? Can you see my cursor here? Okay.
Yes, sir. I
So
can.
for
Yes, sir.
what you can do, you can calculate this area, right? It will be length into
Breadth. Width.
similarly for area for this length into
Okay.
breadth and fill
Width.
say area, and you can add you
Add
can see
all
whether
the.
it's a
I got it.
no valid PDF or not. So this is something I mean no, this is something you can see and all. Okay. Now, so next is exponential distribution. So I will write the first PDF form of exponential, and then I will give you some example for that. So what is the exponential distribution? First of all, a continuous random variable, okay, whose probability density function is given as, let's say there is there is a parameter lambda which should be greater than 0. So let's say this probability is given as, I mean PDF is given as lambda into e raised power minus lambda times of x. Here x should be greater or equal to 0, and it will take value 0, otherwise and probability will be this is something called exponential distribution. So for this is the PDF exponential. So for different values of your lambda, for different values of lambda, you will get different kind of curve. Means for some value of lambda you can get this kind of curve, for some value of lambda you will get this kind of curve, something like. So this is meaning exponential distribution. So thing is that when to use this exponential distribution. So exponential distribution means basically you can use when like you are interested in the distribution of the amount of time until some specific event occurs. Okay. If it's not clear, I will take some examples that will give you the clear idea. So what I'm saying,
Sir, what will be the point of lambda, sir? You said the lambda which in y-axis it will start, right?
no, this is fx. This will give you, no. So this means for different values of lambda. So this graph or for different values of lambda, you can try for different values of lambda, you will get different kind of exponential curve.
Okay.
For some value lambda, you can get this kind of curve. Okay.
That
Understood?
is expectation.
Yes, sir. Got it,
Yeah.
sir.
So yeah.
The
So
point
that is
it
the
will
different.
start.
Yeah. Okay. Now, so when this exponential occurs, whenever you are interested
Sir.
to model the time, let's say, saying exponential distribution, you can use exponential distribution. I can write, let's say, often arises, as the whenever I'm interested, as the distribution uh, of the amount of time, what kind of, until some specific event occurs.
Sir.
Okay. So yeah, 1 minute, please. Okay. So actually, exponential distribution is also useful. Actually, we are not. I mean, that's the bit advanced statistics called. Maybe some of you had. Any one of you have heard about Poisson process and all?
No, sir.
No, sir.
Okay. No worries. That's not in our stats course and not going to come in your interim exam. So that like actually exponential distribution, it's very useful in Poisson process and all. You can search, do a Google and all. So yeah, someone was asking any question. Yeah.
Yes, sir.
Yes.
Sir, I haven't received the email regarding this.
Okay, we can ask that question later. Sir, continue.
Later. Sir,
I
please stop.
thought you have doubt some technical. Okay, so please try to ask general doubt at the end
And
of
the
the
session.
So here, what kind of distribution? So whenever you are interested in distribution of time, amount of time until some specific event occurs. So for example, okay, let me tell you the formula before that. Then I will move on to this part. Okay, so that we'll do the some question direct. So if I'm interested in the CDF f of x, so what should I write? Probability x less or equal to x, right? So how I can calculate this? So for this, what you have to do? You have to integrate from 0 to this point, right? This
So
particular
0 to x.
So I have to integrate 0 to x f of x dx, right? So 0 to x lambda e raised power minus lambda dx. So if you will integrate this, right? So you will get 1 minus e raised power minus lambda times of x. Okay. So I'm not doing this whole integration. You can directly, I mean, if you're interested, you can do. If you'll integrate this part, you will get. So you can see here, what is the CDF of exponential distribution? 1 minus e raised power minus lambda x. Okay. So this is useful. I will tell you why. And another formula, expectation of x is nothing but 1 by lambda, and variance of x in case of exponential distribution is 1 by lambda square. So these are all things we can get when I to integrate x fx dx, and this I have to solve expectation of x square minus expectation of x whole square. Okay. Now, okay, okay, let me take one example. So for example, suppose I'm saying there is example. Let's say you went, I mean, there is a coffee shop which is very busy. Busy means, let me write the questions. At a busy coffee shop, okay, customers arrive. At an average rate of 10 per hour. Okay. Let's assume, assuming this, time between arrivals. The time between the arrivals of customers. Suppose I'm saying arrivals follow an exponential distribution. Okay. Now my question is, what is the probability that next customer will arrive within 5 minutes? Okay. So now here you can see, first of all, here you can see, now question is clear. Here I'm interested in distribution of time, distribution of the amount of time until some specific event occurs. No, okay. So what is the exponential? Okay, first of all, here x follows exponential distribution lambda, right? Okay. Now what is the expectation of x in case of exponential distribution? It is 1 by lambda.
Yes.
Right?
Yes.
Now question is, and what was the f of, okay, question is, here if you see, lambda is not given directly, right? Here it is given average rate of 10 per hour. Are you getting my point? So there is a twist. You too, while you are doing questions related to exponential and all, be careful, because sometimes in the question lambda will not give you directly. They will give you the 1 by lambda. So here this is 10. Yes or no? Are you getting me?
Yes.
Yes, sir.
Okay. Average
Yes,
rate
sir.
is 10 per hour. So what will the value of lambda here? 1 by
0.1.
1 by 10, right?
Yes.
Yes.
Yeah.
One second. Before going to average rate, I think average rate is 1 by 10. Okay, one second. It's in hour and minute. Okay, so let's do like this. I will take this. Okay, so let's say we can say customers arrive at 10, rate of, let's remove this average.
Minutes.
Yeah, 10, yeah, actually
Yes.
with the at a rate of 10 per hour, for example. So what is the value of lambda here? 10 per hour, right? Okay.
Yes.
So basically this is in hours, so it should be in minutes. So what I
Make
have
the
to do, I have to
minutes.
divide by 60, right?
Yes.
So what it will be? It will
1
be
by
1 by
6.
6, right? Now, so question is, what is the probability that it will be like probability that next customer will be within 5 minutes, right? So that means what? I have to do x less or equal to 5. Yes or no?
Yes.
And we know what is the f of x. Probability x less or equal to small x in case of exponential distribution. It's 1 minus e raised to power minus lambda x, right? So it will be 1 minus e raised to power minus lambda is 1 by 6 lambda into 5. So it will be e raised to power minus 5 by 6. Yes or no? So, okay, there is another approach. You can integrate from 0 to 5 this lambda e raised to power minus lambda dx, or you can say 0 to 5, 1 by 6 e raised to power minus x by 6 dx. You will get this answer. Okay. So if you are not aware about this, integration part, you can use the CDF formula directly, but you have to be careful. Okay, basically this formula will be given to you. Okay, careful means what is, suppose what if I will ask what is the probability that next customer will come after 5 minutes, then what you have to do? 1 minus probability x less or equal to 5. Correct. So you can do 1 minus, what is the value for this? X lesser than equal to 5. 1 minus e raised to power minus 5 by 6. Yes or no? So 1 will get cancelled out. Basically, it will be 1 minus 1 plus e raised to power minus 5 by 6. It will get cancelled out. It will be e raised to power minus 5 by 6. Correct?
Yeah.
Now this is clear.
So we could have also
Yes, clear.
converted 5 minutes to hours, right?
Yeah, you can convert, but it's good to convert this minute part. Okay.
Minutes.
Yes.
Now let me take the thing which I have erased here. In the next question, let me write. I'm hoping everyone has pen and paper. Suppose I'm saying there is a certain brand of some, let's say, electric bulb. Okay. Okay. What is the case? This light bulb has an average lifespan of 800 hours. Okay. Now, are you can you relate from this previous example? In previous example, initially I gave average, but I removed. So let's say 10 per hour, right? Now I'm giving average lifespan of 800 hours. Yes or no? Right. Now, question is, suppose I'm saying this lifespan, suppose this lifespan of bulb, if lifespan of these bulbs, let's say, follows an exponential distribution, okay. So question is, let's say, what is the probability that a randomly selected bulb, let's say, will burn will burn out within, let's say, 300 hours. Okay. Now tell me, we do okay. So x follows exponential lambda. What is the expectation of x? In case of exponential, it's 1 by lambda, right? So in here, what value of lambda is 800. Is 800?
Yes, yes.
Yes.
Yes, no. If you focus carefully, I'm talking about average lifespan.
Lambda is equal to 800, sir. Here.
Lambda is not 800 here. Here I'm talking about average lifespan of 800 hours. So expectation is given to us as 800 hours. Yes or no?
Yes, sir.
Okay.
Yes.
Okay. While in the previous question, I directly gave 10 per hour, right? But in this case, you have to be focused. That's why I removed from the from the previous question, so that you can do the differentiate here. So here it has been given average lifespan. That means expectation of x is given as a 1 by lambda, which is 800. So value of lambda will be 1 by 800. Yes or no? So be clear with this. Sometimes people make mistake here. They directly
Sir,
assume.
Can you please show the previous question just for a second?
So in previous question, it was given directly customers arrived at the coffee shop 10 per hour.
Okay.
Okay. Here it was not
Okay, the whole
average.
lambda value was given.
Correct. Yeah. Okay. Now,
Here expected values.
correct. Okay. This is fine. Are you able to relate?
Sir? Sir, we consider lambda to be the mean. Is that correct?
No. Lambda is the rate parameter of exponential distribution. 1 by lambda is the mean. Expectation of x. Yeah. That don't relate with Poisson. Poisson, in case of Poisson, expectation and variance is same as lambda, but here it's a different case. Okay.
Sir, can you just repeat what you just said? Rate of?
It's a rate parameter. Means rate parameter, I'm interested in distribution of the amount of time until some specific task, specific event happens. Okay. Now, so question is, you can see what is the probability that the randomly selected bulb will burn within 300 hours. So what is the meaning of this? What should I write?
X less than equal to 300.
Less than equal to 300.
Okay, so I can apply the CDF formula directly.
Yes.
Yes.
What is the CDF formula? 1 minus e raised power minus lambda times 300.
Yes.
Yes, sir.
And what is the lambda? 1 minus e raised power
1 by
minus
800.
3 by 800. Right? So whatever the value you
Yes,
will
sir.
get, you can calculate. Right? So some sort of rough idea is clear to all of you?
Yeah,
Yes,
yeah,
sir.
we got it. Thank you.
Okay. So suppose I'm saying that randomly selected bulb will take at least 400 hours to burn out. So what should I write? X greater or equal to
400
so this I can write
equal to
1
1
minus
minus.
probability X less than 400. And for this particular part, I can apply the CDF formula. And what is the CDF formula? 1 minus e raised to power minus lambda times of X. So 1 minus e raised to power minus lambda. Lambda is 1 by 800 and X is here 400.
400.
So it will be 1 minus 1 plus e raised to power minus 1 by 2.
Yes.
So it will be e raised to power minus. Is this clear?
Yeah, clear.
Right?
So sir, in every cases, first we have to like convert it in CDF.
Yeah. If you don't know the integration, go with the CDF form. Okay, that's why I'm taking some different example. Suppose I'm saying a randomly bulb selected bulb will burn, or it will take some time between 300 hours to 500 hours. Then what should I write here? Yeah, what will be the next step?
Integrate from 300 to 500.
Suppose I don't know the integration.
F of 500 minus F of
Correct.
300.
X would be less than equals to 500 minus
500 minus F of correct.
300.
So for this part,
Correct.
I can apply the CDF. So it will be 1 minus e raised to power minus 500 divided by 800 minus 1 minus e raised to power minus 300 divided by 800. Is this clear to all of you?
Yes, clear.
Yes.
Okay. All. Okay.
Sir, I have one question, sir.
Yeah. Go
In
ahead,
examination, the options will be in this e raised to form, or we will have to.
If option will be in e raised to power like this exponential, in terms of exponential. If it's not, then there is a calculator. You can calculate the value. Okay.
So calculating on that calculator is really.
So this fine. Some okay. This exponential uniform is clear to all of you. Can you
Yes, clear.
do a hand raise if it is clear? Yes, no, or you can simply mention in the chat. Anything is fine. Only few of you, only 2 or 3 hand raise I can see. 6, 8, 9. Okay, all right. So can we move to the next part, or do you want to me take one other another more one other example? If you want to try.
But to go with example.
Exactly.
Okay.
Yeah,
So
take an example.
let me write one example. Suppose I'm saying a customer, there is customer service center receives phone calls at a rate of 3 calls per hour. Okay. Now suppose I'm saying if the time between calls follows an exponential distribution, what is the probability that suppose the time between let's say two successive calls, okay, will be more than, let's say, 20 minutes. Okay, so the similar question we did, but yeah, you have 2 minutes to do it. Okay, do not worry about the final value in terms of e. Yeah, I mean the final value of e raised for something. You can tell me the answer in terms of e itself. Okay.
अगं हा क्वेश्चन दिलाय ना.
Yes, got it.
Yeah, got the answer?
Yes.
Anyone, or still you are trying?
You go ahead with the answer, sir.
So what the answer you got?
So it is a success more than 20 minutes.
Mm-hmm.
So 60 minutes is 1 hour, right? So 3 success calls was the lambda is 20 minutes. 20, 20, 20. So 60 minutes.
Okay, first of all,
Well, the lambda is 20 minutes because at a rate of 3 hours calls per hour, which means one call per 20 minutes. So we can
Yes.
no. Okay, 1 second. What is the value of lambda? 3 hours? Okay.
Sorry?
3 calls.
3 calls per hour.
3 calls per
3
hour.
call per hour. Sorry. Yeah, 3 call per hour, right? Okay. But at the end, we have to calculate the in minute. Okay. So in minute, what will be the value of
Volume.
lambda? It will be 3 by 60 per minute.
Yes, sir.
Yes or no?
Yes, sir.
Okay. So can I say lambda equal to 1 by 20?
Yes, sir.
Yes, no? So value of lambda is 1 by 20 here. And what is the question? Question is probability that x will take more than 20 minutes. Yes or no? Now it will be 1 minus probability that x less or equal to 20. So far so good?
Yes, sir.
Yes, sir.
Now what is this part? This part is the CDF. And we know what is this? 1 minus e raised power minus lambda times of x. So what is x here? 20. What is the lambda? 1 by 20.
20.
So it will be 1 minus 1 plus e raised power minus 1. This will get cancelled out. So e raised power minus 1 is the answer. Is this clear?
Yes.
Okay, got it.
So you have to be careful. Here it was in minutes, right? Here it was 3 calls per hour. So what will be the rate? It will be 3 by 60 per minute. Clear?
Yes, sir. Clear, sir.
Okay. Now, fine. All right.
So there in the
this
question, success, more than 2 success, that little
20.
bit confusing.
No, it's not 2 success. It is asking, basically, suppose you, okay, here you are interested in a call arrivals, right? Time interval between the 2 calls, right? It is saying, saying, suppose one call you got here and another call, it is saying it will take more than 20 minutes to get. I mean, you will get after 20 minutes. So that is the meaning. Okay.
Okay, got it.
Got it?
But it is a 3 calls, right? There can be 3 calls also can be received.
Yeah, why not?
3 calls also can be received, right?
So it's 3 calls per hour. Okay, they are saying 3 calls per hour. That means 1 hour. I mean, within 1 hour they can get 3 calls. Okay, so it's saying between 2 successive calls. Suppose one call you got here. It's saying between 2 successive calls it will take more than 20 minutes. Okay, suppose this is 3 calls you are getting in 60 minutes. You are saying suppose this is the first call and it will take more than 20 minutes to get the second call. That is the part. Okay.
Okay.
Yeah. All right. So next is, how many of anyone of you have seen the uniform or sorry normal distribution? Yes, no?
Yes.
Bell curve.
Okay. Yeah, that's okay. Bell curve. Okay. So one more thing, let me clarify from the portal. So if you go to the portal, so there is till 12.7, right? So I mean this standard is standardizing a normal random variable you have to do. If you go under additional content, so again by mistake in under additional content, so this normal distribution standard and this standardizing this normal variable again in under additional content. So do not think it's an additional content. So additional content is here additive property and geometric distribution. Why? Because these 3 distribution already covered as this lectures. Okay. And also, as I mentioned, there is only one question from normal distribution, which is 2-mark question in your NTEM exam, which is the MCQ or MCQ. So, which is you can do just watching the lecture video or doing the activity. No further is required. But
Sir,
there will be questions from other topics. Okay.
Sir, that approximation rule comes under normal distribution.
Yes. So there's something we will see under normal distribution. What is the PDF of, what is the approximation rule, how to make a standard normal variable, transforming, normal standard normal, how we can do. We'll see additive property and percentile. So anyway, this additive property and percentile is covered under the additional content. Basically, I will give you some rough idea about this part. Okay, this standard normal normal distribution, this 12.5, then 12.6 standard normal distribution, and then 12.7. So I will give you some sort of rough idea about this kind of things. Okay, so what is the normal distribution? Actually, if you will see one important thing, so normal distribution is a very like it plays a very important role in the world of statistics. Okay, anyway, we are going to study in week stars 2 any kind of distribution, whether you have binomial, you have Poisson, you will see some t distribution. Now those kind of things we'll see in stars 2, this binomial, Poisson, hypergeometric, and also whenever your sample size will get large, right? There is called something central limit theorem, under this theorem, irrespective of the distribution, it will converge to normal distribution. Okay, so that's the one of the property that we will do in stats 2. I'm just giving the intuition about this part. Okay, so thing is that what is the PDF of normal distribution? Okay, so we saw the PDF of uniform distribution. What was the PDF? 1 upon b minus a if x follows uniform a comma b. Yes or no?
Yes.
What was the CDF?
Yes.
X minus a
X
divided by
minus a divided by b minus a.
B minus
what
A.
was the expectation? A plus
A plus b divided by 2.
what was the variance? B minus
B
a whole
minus
square
A.
divided by 12.
12.
If you have exponential distribution with a rate parameter lambda, what is the PDF? Lambda into e raised power minus lambda x. What was the CDF? 1 minus e raised power minus lambda x, right? So those we have seen. So in case of uniform, A and B are the parameters of uniform distribution. In case of exponential, lambda was the parameter of exponential distribution. So similarly, in case of normal distribution, we have parameters which is called basically this is denoted as mu and sigma square. So this mu and sigma square are the parameters of your normal distribution. So and this mu is nothing but expectation of your normal distribution, and variance of your normal distribution will be sigma square. Okay, these two are the parameters. So normally we are denoting x follow normal distribution with parameter mu. Mu is the expectation of x, sigma square is the variance of x. So this is something probability density function of normal distribution, which is 1 upon root 2 sigma root 2 pi into sigma e raised power x minus mu whole square divided by 2 sigma square, and the range of x is minus infinity to infinity. Okay, and what will be the range of sigma square? Range of sigma square greater than 0, yes or no?
Yes, sir.
Because sigma square is what? Variance, right? Variance can be negative?
No.
No, right?
Sigma square is equal to 1.
So what is the shape of normal PDF? So normal distribution PDF is bell-shaped curve, and it is symmetric about value mean mu. Okay, so see what is the meaning of symmetric? This means this is the 50% and this is the 50%. So symmetric means you can say mirror image is same. Okay, so what do you mean? Suppose I'm saying this is value minus a, and we know a normal, what is the limit for normal random variable? Minus infinity to infinity, right? This is minus a, suppose this is a. So what is the meaning of symmetricity? If I'm interested in probability, let's say x less than or equal to minus a, and probability x greater than a, right? So this means probability x greater than a means I'm interested in this region.
Yes.
And probability x less or equal to minus a, I'm interested in this region.
Yes, sir.
Yes or no? So symmetricity means this part gives you the mirror image of this part. That means I will say probability x less or equal to minus a. This is same as probability x greater or equal. Okay, because it's a bell-shaped curve. If you'll fold this, it will it will fit to a one side.
It's a perfect reflection.
Correct.
Superimpose each other.
Sorry?
It superimposes each other.
Yes.
Yes.
So now you can see, here for there is a height of the curve. Actually, height of the curve here you can see for mu is equal to 2. So this peak will be at mu is equal to 2. Okay, and sigma is 0.5 and height is what? 0.79. One more thing, in case of normal distribution, you can see this is a bell-shaped curve, right? This is very important property. In case of normal distribution, this mean is same as median is same as mode. Okay, maybe you have seen your discuss skewed curve, right? Positive skewed, negative skewed in case of binomial and all, right? So
Yes,
those skewness is coming because of there is relationship, mean, median, mode. Okay, you will get some some part, let's say why it's happening. Suppose you are getting what kind of curve this is? Left skewed or right skewed?
Right. Positive.
Positive skewed.
Positive.
Suppose this is curve something like, okay, so at the peak, okay, This will give you the mode because mode is maximum, right? And suppose this is the mean. And suppose somewhere is median. Okay, suppose this is the median. Okay, if you have relationship something like this, and can't call exactly, then you will say this is the positive skewed. Yes or no?
Yes, sir.
Yes.
Similar relationship you can see in case of what to say, negatively skewed curve. Okay, so in case of symmetric curve, or you can say bell-shaped curve, I mean mean, median, mode will be the
same.
Correct? Are you getting?
Yes.
So now, yeah, let's just do a thing about this part. Yeah, so this is the case. Here you can see what is the mean is the same. Yes or no? Mu is equal to 2 because peak is where at 2 itself, right? Okay. So for different value of sigma, right? For different value of sigma, you can see the graph. So for this, you can see this blue. What is the variability? Variability is very less, right? 0.5. So you can see there is very less variability, right? Yes or no in this curve? Okay.
Yes.
If sigma is 1, then you will get this curve. So you can see there is variability from here to here. Yes or no? If sigma is 2, you can see the variability in the curve. But peak is the same. I mean mean is the same, which is at 2. You can get the bell-shaped curve, but based on the sigma, you will get different things. Here, in this case, you can say sigma is the same for all part, but mu is the different. Okay. Here peak is at -2, peak is here 0, here peak is at 2. Okay.
Yes.
So it will basically, so thing is that this normal curve is symmetric about the mean. Yeah, I have discussed the
So,
same
sir,
thing, right? Yeah, yes.
So, sir, standard normal distribution would be mu is equal to 0 and sigma,
correct.
and
Yeah,
sigma square is equal to 1, right?
1, yeah. I will come to that. So here, it's symmetric means I told you, right? So it's equally likely either side, right? Okay, this is the mirror image. I mean, this blue region is same as this part. Okay, this is the meaning of symmetricity. Okay, so suppose here any point is, let's say, minus a, and this is the a, for example, then I will say probability x less or equal to minus a. This is same as probability x greater than. Yes or no? Are you getting?
Yes.
So these are very key features about normal distribution. Yeah, this is same. So since this is a symmetric, I will say probability x less or equal to mu, this part, and probability x greater than equal to mu, it will be half. If you add this blue and this region, it will give you the area under the curve, which is 1. Understood?
You got it.
Yes. Okay. Now, so there is something called basic like approximation rule, which is very important in case of this normal distribution actually. So what this approximation rule says, suppose there is a normal random variable with mean mu, there is some mean and there is standard deviation. So suppose you are saying your x will lie between mu minus sigma less than mu plus sigma. Okay, so this will give you the 68% area. Okay, suppose there is a question where it is in already asked mu minus sigma, what is the x will lie between, this is called one standard deviation, and this is called mu minus 2 sigma, mu plus 2 sigma, 2 standard deviation. This is called 3 standard deviation. So this blue region means mu minus sigma to mu plus sigma, it will cover 68% area approximately, and mu minus 2 sigma, mu plus 2 sigma, that means this to this, okay, including blue plus this yellow, it will give you approximately 95% probability, and mu minus 3 sigma, mu plus 3 sigma will cover approximately 0.997 probability. So you can see from here to here, it is covering approximately 0.997. So what if you will give me the answer right now? If I will say x is more than 6, okay, let it be. Now you will give me the answer after
0.95.
0.
No.
0.
Yeah, 0.
It's equal to 0. Yeah, almost.
Yeah. Okay. That 6 will be clear in a minute. Okay? So now here you can see, if I will talk. Okay. Let's say I'm saying x is greater than mu plus 4 sigma, for example, it will be 0 or not? Because mu minus 3
Zero,
sigma
zero.
to mu plus 3
Zero,
sigma, it is
zero.
covering this probability, right? This whole region is
Yeah.
almost covered, right? After that, probability will be 0 or not?
Yes, sir.
Yes, zero.
It will be clear in a minute also.
Uh,
So you can see
sir,
based on based on this probability, you can, so this is 0.68, right? This blue region total blue region is 0.68. So half of will be 0.34 and this half will be 0.34 because of symmetricity. Similarly, this total is 0.95. So this will be half of 0.95. This will be half of 0.95. You can find by adding these two value and these two value. Okay.
Yes.
So yeah. So let's see the one of the application here. Application of this. Okay. Treatment. Yeah. Question is here. So question is the height of a certain population of males. Let's say is normally distributed with mean 69 inches and standard deviation 6.5. So what is the mu? 69. What is the sigma? 6.5. So question is what is the probability height is less than 82? Okay. So how we can calculate? So what is this 82 represents here? So 82 represents is what? 82 is what? Mu minus. Yeah. Okay. You can do from here. So what is 82? Mu is 69. Sigma is 6.5. What is this 82? Probability x less than 82.
So it is mu plus 2 sigma.
Mu plus 2 sigma. Sure.
2 2.
Right. So I'm interested here. Probability x less than mu plus 2 sigma.
Yes.
Sir, we are interested in blue part, right? You said. Or
No. Up to he's asking the entire curve.
Entire curve would be total, right? I mean.
So what will the probability x less than 82?
Less than 82, 1 minus that mu plus 2 sigma.
Yes or no? Right?
Yes.
So if you put 69 here, 69 plus 2 times 6.5, it will be 82, right? So can I'm interested in this region, 1 minus this region?
Yes.
Yes or no? I can do 1 minus this part, or else I can add all these values.
Yes.
Yes or no?
Yes, sir.
Yes.
So probability we can see. Let's
Sir,
verify. Yeah, basically
how
this
did
is.
you get 82?
Yeah, so mu is 69 plus 2 sigma is 6.5. Okay. I'm interested. Yeah, less than. So I can do this probability x less than 82 is nothing but 1 minus 0.024, which is 0.96. Yes or no? Basically, what we are doing, x less than mu plus sigma, this is same as 1 minus probability x greater than mu plus 2 sigma, and 1 minus this is 0.024, and this value is nothing but 82, so it will be 0.96. It is fine.
Yes.
Okay. So suppose this is again something. Suppose I'm saying x is follows 15,4. Okay. Then what is the probability that x is less than 23? So what is that 15,4? 4. Yeah. So this is mu. This is sigma. So 15 plus 4 into, let's say 2. So 15 plus 8, which is 23. So what is this? Here I'm interested mu plus 2 sigma, right?
Yes, sir.
So what is the, again, 1 minus this part, right?
Yes.
Okay. What is the probability x is less than 11? So less than 11 means mu
blue part
minus 4 into
minus sigma.
Only 4, right? Mu minus sigma. Okay.
Yes.
So you can see what is the value of mu minus sigma here. So mu minus less than sigma is this part, right? These two values we have to add. Yes or no?
Yes, sir.
Yeah. So basically you can use the approximation rule if you don't want to see. In case of normal distribution, integration is very, very tough. Okay. Because you
either
to,
we can sir, either we can deduct, or either we can add it.
Yes, we can add it.
Yeah, you can add it. Yeah, you can accordingly, as per the question you can do. Actually, standard normal distribution is very, very useful. Yeah, here you can see this expected value is given to you, standard given value. So y is also okay. So this is something. What I'm trying to say, let's do this standard deviation part. This is a very important. So why? Because whenever you have been given, okay, so there is something called standard normal, table.
Hello, sir.
In case of, yeah, 1 minute.
Hello, sir.
So yeah,
Sir, I have one question in previous question.
okay.
Could you please go to that
Yeah,
statement,
tell me,
question statement?
tell me.
Sir, generally we write normal distribution as
Mu comma
n
sigma square.
into, yes, sir, sigma square, and value for sigma square is 4. So
No, it's okay. Here it is given as no. Okay, so some books refers normal mu comma sigma square, but here it is clearly we are saying normal mu comma sigma. So here they are
It's a
referring
standard
this
deviation.
standard deviation. Okay.
Yes.
For example, generally we are denoting x follow normal mu comma sigma square. If it is sigma square, it will be clearly mentioned. Okay.
okay, sir.
Okay. I mean, it will be clearly
Because
mentioned
same
what
in the
is the.
lecture, I guess. Yes, sir. In lecture, in same sigma square and sigma. So I got confused
Oh,
where
no,
when to
do
use
not worry.
standard
Actually,
deviation.
here sigma is directly taken as a 4. Okay. But normally we are taking sigma square, but it's still in normal quizzes and all, it will be clearly mentioned whether this parameter is sigma square or this parameter is sigma. Clear?
But in the calculation, it is sigma only,
Sigma.
not a sigma square.
No. Yeah, it's a
It is
sigma
only
only.
standard deviation.
Correct.
Yes.
Okay.
Yeah. That got I got that mu plus sigma and mu minus sigma. But in the if the question is
We
given
should
like
convert it.
yeah.
Correct.
Yes.
It will be it will be clearly mentioned. Okay, do not worry about those
Please
things. Okay.
Okay, sir. Yeah, thank you, sir.
In the question paper, if it is not mentioned, is sigma or variance?
Yeah.
Sorry.
Sorry, could you please repeat it again?
So he is saying
if mentioned clearly, if they just two numbers, are we supposed to treat that as a standard deviation or
go with the variance?
If it is not mentioned, it should be taken as
Correct. So why I'm saying some books, not some books, most of the books, they are taking normal mu comma sigma square. Suppose I'm saying x follow normal 50 comma 16. So this is the mean and this is the sigma square. Okay. So in this question part, actually, if you see in the beginning of the slides, ma'am mentioned x follow normal mu comma sigma square, where mu is the parameter and sigma square is the variance. Okay. Now you can see this is the part. Okay. But in the question, by mistake, ma'am took as a sigma, but you can go with this. Okay, not a problem. Or sometimes, like not sometimes, most of the times we are mentioning clearly what is the meaning of that parameter. Okay. Suppose rather than this, I can write x follows some normal distribution with mean this and with the standard deviation, let's say 4. Okay. Then you can write here normal with mean standard deviation will be, variance will be 60. Clear?
Okay.
Yes, sir. Yeah.
Okay. Yeah.
Thank you, sir.
So yeah. Thank you. So what I'm trying to say, discuss the next thing, which is called standard normal distribution, which is very important, because whenever you have been given no questions related to normal distribution, so you can convert your normal random variable into standard normal variable. So why is that so? Because there is a standard normal table, so almost all kind of probability you can find value of the probability. I mean, it's called basically abject table. So not okay, what
Z
is this
table,
capital
Z table.
yeah, G table actually. Yeah, so this capital F represents probability capital G lesser equal to small z. Okay, so this capital Z is nothing but standard normal variate. We will see how to convert a normal variable into a standard normal variable in a minute. First of all, we'll see what is the standard normal variable. So when your mean is 0 and the standard deviation is 1, if your standard deviation is 1, so sigma square will also be 1. When your mean is 0, variance is 1, I will say that random variable is a standard normal variable. So initially what we saw for normal distribution, peak is at mu, right?
Yes, sir.
Now, in this case, peak will be at
0.
0 because mean is 0 itself, right? So this area will cover 50% and this area will cover 50%. So can I say probability X, let's say Z, I'm denoting Z as a standard normal. Z less than or equal to 0. This is same as probability Z greater than 0, which is half.
Yes, sir.
Would you agree with me? No. So this is standard. So if I will write this part, probability X less than Z less than -2. This is same as probability Z greater than 2. Suppose I have given probability Z greater than 2, and question is find the value of probability Z less than -2. So that will be the same, because Z
same.
less than or equal to -2. This is same as this part.
This is same.
Okay. So now approximation rule will again here be true for this standard normal variable, because this 68% was for mu minus sigma to mu plus sigma, right? So here mu is 0, sigma is 1, so it will be -1 to 1.
Yes, sir.
Yes or no? And then mu minus
Mu
2
minus
sigma
2
to mu
sigma.
plus 3 sigma.
3,
Sorry,
like
2
2
sigma.
sigma.
So
Yes, sir.
minus 2 to 2, because mu is 2, sigma is, sorry, mu is 0, sigma is 1. Similarly, mu minus
Mu
3
minus 3
sigma to,
sigma. Mu minus plus 3 sigma.
now,
All
can you tell me, if I will ask, what is the probability Z will greater than 4? Tell me, what will the probability?
0.
0, sir.
0? Because
Yes.
probability Z less than till 3, it is covering approximately 0.997, right?
7.
Are you getting? So
Yes, sir.
lot of statistic hypothesis testing you will do in stats 2 course. So thing is that whenever you are going, suppose you made a hypothesis called null hypothesis, alternative hypothesis, and you have to make a decision. Let's say your hypothesis is on an average life of this bulb is, let's say 100 hours. This is your hypothesis, and at the end you performed your testing and all, and you got value of Z as a, let's say 6. Okay, then I mean your value of probability Z less than that value you got as a 6. That means what? Sorry, I mean probability that Z you will get greater than 6, for example, that will be 0.
Yes.
Okay, then accordingly you can take your decision and all. So this approximation rule is very, very important. Again, the lot of time I'm saying the things which are not going to, we are not doing stats one, but it's important. This is called something quality control. Okay, if you are interested, or after your end term exam you can search. So whenever you will do statistical quality control, right? So this approximation rule is we are using more number of time, most of the times. So in quality control we are specifying lower specification, lower control limit and upper control limit. So that is this part actually. This will give you the lower control limit and upper control limit. Based on this, suppose you are owner of a manufacturing company, so you can decide the upper control limit. After that you will not you will reject the something. Okay, this is mu minus 3 sigma will decide your lower control limits. That is something beyond this, but I'm just trying to give you the intuition behind this kind of things. Okay,
Can I
now, so yeah, please.
Can you go into this slide 618, slide number 18?
18. Okay. This one?
Yes.
Okay.
See, the description of the distribution is 15, 4. Then sigma is 2.
Yeah. So here I think ma'am took sigma as a 4, right?
How? I mean, if that is
yeah, that is the type.
My question is only in the exam hall, we do not have a clarification.
No, there will be
numerical answer is asked. I assume it is a sigma square. My answer will be different.
No. So what I'm saying, X follow normal mu comma sigma square. Okay.
Correct.
First of all, specification will be given, because yeah, I know because we have created the QP.
Here is different,
is
sir.
given. Yeah, that all things will be specifying there. First thing.
Okay,
second
sir.
thing is there.
Problem is not
if it's
about
not
the concept. Concepts are clearer. But
yeah, if it's
the
not,
way the questions are asked, we are not used to, at least I am not used to. So I get it different interpretation, then I get into
no. Go with this. If it's nothing mentioned, right? Go with this. Your question will not be wrong. Okay. If it's there is something different, it will be clearly mentioned whether it's a sigma or not. Okay.
That's okay.
So okay, fine.
So
So
100% you will be giving the clarification in the exam.
yeah,
Hope so.
yeah. 110%. If there is something happen,
Thank you.
you can like
Okay. By
cross.
default, we can take it's a sigma square.
Correct. So
Done,
that's
done.
the most of the books refers. Okay.
Mhm.
So here, what you can do?
Sir, I got confused. I mean, here you are taking sigma as a standard deviation or variance. I mean,
No.
I mean,
Sigma is the
square
standard. Sigma is the standard deviation. Sigma square is the variance.
Variance.
Okay. In that particular question, by mistake, it's a 4.
Yes.
Okay.
Okay.
It should be 2, but by mistake it's 4.
Slides.
But
No, it
do
should
not
be
worry.
16,
It will be.
sir.
It will be. Yeah.
It should be 16.
Yes.
Yeah.
It's not one slide. It's many slides.
Yeah.
Is it? Okay. We'll correct it. Okay. We'll correct. Do not. Okay. Now. Okay. The idea is clear, right? So I'm saying it will be clearly
Yeah. Idea is
mentioned.
clear.
Okay.
Yes,
And
sir.
if
Yes,
it's
sir.
not, go
Yes,
with
sir.
the sigma square. Okay.
Okay, sir.
Okay. Sometimes I can mention, let's say x follows normal mu comma sigma square. Okay. Suppose question is something like that. Let's say mu is 2 and sigma is 4, for example. Then you can directly write here normal 2 comma 16, right?
That's
Suppose I'm saying,
Oh.
yeah. This kind of specification will be there. So do
We're
not
only
worry
talking
about
about ambiguity.
Yeah. Do not worry about that ambiguity. Here it's there. We will correct this. But thing is that it will be clearly mentioned. If it's not, just go with the mu comma sigma square.
Okay, sir.
Okay. Yeah. So here, suppose question is probability. What is the probability z will lie between -2 and 2? Then what is this? This is no 2 standard deviation, right? Because mu minus 2 sigma, mu plus 2 sigma, mu is 0, sigma is 1, so -2 to 2. And we know this if axis lies between mu minus 2 sigma to mu plus 2 sigma, it covers the
It's 99.
95.
Okay.
95. Okay, 99.7 is mu minus 3 sigma and mu plus 3 sigma.
Okay, got it.
So what is this probability z greater than -1?
Sir, it's mu minus sigma, sir.
This g greater than 1, right?
Yes, sir.
Yeah. So similarly, you can find, right? Or else you can calculate this part. Sorry, this whole part. Or else you can subtract 1 minus
1 minus this part. Yeah.
Okay, you can find this value. Okay, so anything is fine. Okay, you can go with this part. So similarly, you can calculate. Yeah, I told you, right? Probability z greater than 4 is 0. So probability z greater than 3 is 0. Okay, because after this you can see it's about close to 0, right? From the graph, it's already clear. Now this part we can already see, right? Probability z. Okay, how we are getting? First of all, tell me probability z less than minus x. I can write probability z greater than x. This will be same.
Yes, sir.
Yes, it's same.
And this is the z greater than x. I can write 1 minus probability z less than x.
Yes.
Are you getting? Okay.
Yes.
Yeah. So same thing. These are the formula we have seen. Yeah. So this part we have also seen, right? So what I can write this probability z less or equal to b minus probability z less or equal to a.
Yes.
Which is this part. Since this is a continuous. Since this is a continuous, equality doesn't matter, right? Okay. Yeah. So this difference you can see like this. Okay. So this blue region, how I can find this blue region? If I will subtract this whole part minus this part, this you can say, let's say yellow part. If I will subtract from yellow to this green, I will get this blue. Yes or no?
Yes.
If I have to from this total part, I will subtract this part. I will get this blue part, right? That so you can think like this also. Okay. So these formulas, it's not something random. It's from conceptual level. And what about this? So this probability z greater than a. I can write probability z greater than a or z less than minus a.
Less than a.
I can write probability z greater than a plus probability z less than minus a. Right? And we know what is this part? Probability z greater than a.
Less than a.
1 minus probability z less than a. Yes or no?
Yes.
And this probability z less than minus a, probability z greater than a, this will be same as. So 1 minus probability z less than a plus 1 minus probability Z less than A. This will become 2 times 1 minus probability Z less than A.
Yes, sir.
Correct?
Yes.
So these kind of things is, very straightforward. Yeah, this part you can try to understand. If I will ask what is the probability Z less than or equal to A, this will give you the CDF. Yeah, this is the standard normal table actually. This is one snippet of the standard normal table. So like how to see the value. Suppose I got the probability Z less than or equal to, let's say 0.1. So 0.1 is what? This value. So 0.1 here, and after 1, this is
0.5398.
0.5398. Suppose I will ask what is the probability Z less than 0.11. So 0.1 here and second decimal from here. So value will be this one. And probability Z less than or equal to 0.12. So 0.1 this, 12 this. This will give you the value. Okay.
Okay. So it is the Z table always you can consider as a less than or equal to.
Yeah, less than or equal to, always.
Equal to.
Yeah, it's a Z table.
So if the question asks for
like
greater than or equal to also, so you have to convert as less than and you have to convert.
Correct. From here you can see if probability Z greater than 1.1, then it will be 1 minus probability Z less than 1.1. Correct. So what is the value of 1.1 here? You can see 0.8643. So 1 minus 0.8643, which is this value. Clear?
Correct.
Correct. Yeah. So this is something Z table and all. You can explore more on it. So I will give you the now I will discuss the what is the yeah, this kind of things you can find probability Z less than equal to nil, less than 1 point. So this will be Z, basically it will be minus 1.64 less than Z less than 1.64. Okay. Then you can write probability Z less than 1.64 minus probability Z less than minus 1.64. Right. You can convert this in a positive and you can convert, and then you can calculate the value from the Z table. Are you getting?
Yes, yes.
Okay. So this all kind of is there. Let me give you the how to calculate this normal variable to standard normal variable. If you have X as a normal variable, so how to convert a standard normal variable? So what you have to do, you have to subtract the mean and divide by standard deviation. So Z is what here? X minus expectation of X divided by square root of variance of X. Okay. So thing is that so this will follow normal 0, 1, and we saw a random variable called standard normal random variable when mean is 0 and variance is 1. So let's see how to find this proper these values. Start from here. So let's say X follows normal, mean mu, variance is sigma square. Okay. So if I'm saying let's say Z is X minus mu divided by sigma. Okay. Before okay, what will be the first of all, what is the expectation of Z? Expectation of X minus mu by sigma. I can write 1 by sigma expectation of X minus mu, right? It will be expectation of X minus mu divided by sigma. Yes or no? And what is the expectation of X? Mu.
So mu, yeah.
Mu minus mu divided by sigma, which is 0. So expectation
0,
of Z is 0. So mean of standard normal variable is 0.
Yes.
Yes or no? Now let's come to the variance part. So what is the variance of Z? So variance of X minus mu divided by sigma. So sigma is the constant, so it will be 1 by sigma square. Would you agree with me? And variance of X minus mu, mu is the one of the value which is constant. So there will not be any effect by adding or subtracting a constant with the random variable in case of variance. Yes or no? So this will be variance of X divided by sigma square. Variance of X is sigma square divided by sigma square, which is 1. So it is 1. Now is it clear from where we are getting mean as a 0, variance as a 1?
Yes.
Okay. Now, all right. So similar thing you can do here. Let's say it has been asked what is okay. How to convert? Suppose there is question probability X less than A. Then how to suppose this is the question, and I have given you, since in case of normal distribution, we can't. No, integration is very tough. It's like there is not a closed form for in normal distribution. If you want to calculate the CDF and all, there is no closed form for that particular integration. So what we are doing, we are referring to this G table. So what what is the G table? So what I can do, I can convert this as a standard normal variable. How I can convert? I have to subtract the mean divided by standard deviation. The same thing I can perform on both sides of this inequality sign. Yes or no? Now this will be as Z, and this will, you will get some value, and this, for this value you can see from the table itself. Let's say this question. So this question says, suppose IQ examination scores for students of a particular school normally distributed with mean 140, standard deviation is 10. Question is, what is the probability that randomly chosen student has a score of greater than 130? Suppose this is the question, and you have standard normal table. So what you can do, you have to convert in standard normal variable. How I can convert? I have to subtract the mean. What is the mean? 140. What is the standard deviation? 10. Greater than 130 minus 140 divided by 10. Yes or no? And this will become Z. Z is greater than minus 1, and this is the value you can calculate from the table. Is this clear? How we can convert in standard normal variable? Okay. What about this part? So this part here, mean is the mean? Yeah, mean is 140, standard deviation is 10. So how I can convert this 110? What is the mean? I have to subtract. We know how to get standard normal variable, x minus mu divided by sigma. So mu is 140, sigma is 10, less than x minus 140 divided by 10, less than 150 minus 140 divided by 10. Okay. So now from here, what I can get? 110 minus 140, that is minus 30. Is this correct? Here minus 2 to 1. It should be minus 3, right? Minus 30 divided by 3. It should be minus 3. And this is Z. And this is 1. So it should be minus 3 to 1 actually. Okay. Okay. Now this idea is okay, everyone? How to convert in standard normal variable and all? Okay. So basically you have to subtract the mean, and so these kind of problems you can see, right? If you subtract the mean, probability x greater than 12, so it will be probability x minus mean is 10, standard deviation is 3, greater than 12 minus 10 divided by 3. Okay. So it will be 12 minus 10, 2 by 3, which is 0.6 and 0.67, and this will be G. You can see this value, and this value we can directly check from the standard normal table. Okay. So these are all problems you can refer from the slides. Yes.
That table you said won't be provided, right?
Yeah, it will be provided if there is question, but fortunately there is no question, but there will be question from normal distribution, which is related some 2 marks question. So accordingly, yeah, there is only one question from normal distribution. Okay. So these are the questions you can see, right? These are the some real life examples and on manufacturing bulb and all. All we have to do from with the help of normal distribution. So just go with this and try to solve more number of questions. Anyway, this additive property and all, okay, and percentile and all we have given and as additional content, but till standard normal distribution you have to yesterday and all. Okay.
Okay.
Fine.
Sir, these slides are in supplementary content.
Yeah, under supplementary content is there. You can find there. Okay. Anyway,
that additional content is not there in the portion.
Sorry, could you repeat?
No, it is not in the portion. I mean, syllabus.
No, it's not in their syllabus.
Not
Yeah,
in
one more. Yeah, one more thing. Let me clarify. Actually, there is kind of. So by mistake, under additional content, okay, this normal distribution, standard normal distribution, and this standardizing a normal random. So this video is there, but do not think this as additional content. Additional content is this additive property in percentile and geometric distribution. But anyway, this normal, standard normal, and this standardizing and normal random variable already here. Okay, 12.5, 12.6, and 12.7. Yes. Okay.
Sir, so this end term is new to me. So 1.5 hour exam. So how many questions?
Approximately 15 to 16.
Usually it is 13 to 14. So 1.5 hour, so 15
Yeah,
to 16. The question level will be difficulty
like
level will be increased or what?
it's not. I think I need to check the exact number of question.
Mhm.
But you'll be able to do within the that 1.5
Timeline.
timeline. Yeah, questions.
90 minutes.
Is it one
So
and a
that's
half?
okay.
Approximate marks.
Yeah, 1.5 hours, sir. 1.5
Yeah,
hours.
end term is 1.5 hours.
6 hours?
Yes.
So 2 part, I hope so.
Yeah. Morning session and afternoon session.
Afternoon session.
So
It's there in the dashboard.
and I think week wise
Yeah.
guidance is given to all of you, right? So
So, sir,
you can
expecting some refresh drinking lunch can be provided by IT, sir. 6 hours, no.
They don't have to provide, they can allow us to take it inside.
So
No, sir, there will be breaks, sir. I hope so. After 2 exams, they will give some breaks. I hope so.
Yeah,
After,
around
Nilandra,
half or 1 hour.
you can ask for one bed also.
that that would be fine,
I'm
sir.
eligible for 20 minutes extra per hour. Now, if it is a 6 hour, then I probably will be sitting for 8 hours. So interesting.
What
No, sir.
If you're like, it depends on the subjects you have
did
taken.
Did you get the hall ticket till now or not?
Not, sir.
Not yet.
No, not yet.
They will mention what are the subjects you have to give in the.
Yeah.
It depends on the subjects. For example, if he has taken, somebody has taken 2 subjects, so he need not have to appear for the first or the second.
Correct. He has to appear only the either shift, morning or correct. Understood. Yeah.
Sir, last time, last quiz 2, you took a mock session. It was very useful to clear the exam. And the same kind of blueprint questions were there, and I found it was easy. Seriously,
Yeah,
I'm not
exactly.
joking.
So
Thankful for that.
Okay.
And I'm expecting the same for the end term, so that you can give me what kind of questions we can expect, and these are all some important questions.
Mock we have released, right?
Yeah, released, yes.
One thing I can assure you, the type of questions we have discussed 2 days, right? More than 20 minutes, at most 20 minutes, or between this. So the question will be like this only. If you got the idea, I can assure you, you'll be able to solve the
Thank you, sir.
questions. But anyway, any of us will discuss the mock session. And one more thing, there is one revision session of week 9 and 10. I think it's on Sunday, 6 to 8. So
Yeah.
please,
Sir, but we request you to conduct the mock session,
Yes,
sir.
sir.
I don't want somebody
Yes,
take
sir.
the session, because
Yeah, I agree with Nilandra, sir.
seriously, I was gone through one lectures, and one weekly summary you didn't take from 9 to 12. I don't want to mention. It was totally I didn't understand actually. There was very few people, and you didn't take one of the summary of from 9 to 12. We just remember, I'm attending all the class of yours.
Along, I think I
Yeah,
took
you are
week
right.
11. I took week 11.
You took week 11, but
Yeah.
9 you took. I also 10 you
Yeah,
didn't
that's
take. I
okay.
hope so.
I agree. So thing is
All
that
sessions, sir.
I will tell you the scenario
Okay.
why it is happening. So thing is that particular instructor, right? So they are in 2 to 3 courses in a particular term. Okay. Suppose today is week 9 summary, and I have to take session in other subjects. So because of
Okay,
that,
understood.
so
But try
actually,
to understand our problem also, and
yeah.
hope everyone's expectation of you to conduct the mock. Thank you.
Yeah.
Anyway, I will try to come. If
Sir, one more doubt I just wanted to raise, sir. Sir, in activity, that extra activity, sir, like it doesn't matter, right? Many, I mean, peer reviews doesn't matter. Is it matter, sir? I mean, many people are giving. I mean, all I have followed all the instruction provided by the faculty. That all the steps I have followed every steps, right, sir? Still, they are giving like 30, 20.
Okay. So no worries.
50.
So thing is that what happens sometimes, suppose I'm going to check your activity, okay, and I'm lazy kind of person, I will simply give some 30 marks or 0 marks or 10 marks, and I moved on for the another activity, okay, something like that. So thing is that while we are doing scoring for extra activity. So we are getting lots of discrepancies, and for those particular set of people, we are checking the activity from our end. Okay. So what happens? So there is two cases. One case, suppose from the peers you got, let's say 80 overall. Okay. But when we are checking, it might be more than 80 and it might be less than 80 also, right? Suppose you got, suppose from peers you got 80, but when you score pushed, you got 50, because if we checked and according to us, we gave the marks according to us. Okay. That is the one of the possibility. But if there is a discrepancy, do not worry. Okay. So we
Yes,
can,
sir, because few people are commenting like Ganda, Barbad, or something like that.
Thing
So
is
they are
that, okay,
commenting,
actually
sir.
that shouldn't happen. People should maintain the, that decorum of the thing. But
Another quick question on the weightage. We got an email that week 1 to 4 is 20%, and then 4 to 8 is 20, 30, and then last is 50%. Is that weightage is really true for actual exam paper that you said? Or?
It's a true.
Okay.
I myself given that weightage actually. So it's
Okay.
a weightage after preparing the question paper. Okay. So this weightage is from based on marks. Okay. What there is 50 to 60% marks from 9 to 12. Also, I'm mentioning again and again, there is only one question from normal distribution, which is of 2 marks question, but other questions will be from other topics. Okay. So accordingly, you can prepare from the normal distribution. So normal distribution, because why we given less weightage from normal distribution? Because in week 12, content is a bit lengthy. So that's why I'm mentioning specifically. So from normal distribution, if you watch the lecture video and you attempted the activity, that is more than enough to attempt that questions from the normal distribution.
So the normal distribution will be continue for stats too.
Yes. So normal distribution, you can say it's the root of statistics. Okay. Without normal distribution, statistics is nothing actually.
So that it is very helpful to if we are studying right now for stats too.
Yes. That's why we have like added the content in stats 1. If you
previously
search,
it was not there.
That's what. So actually what happens when people move to stats 2 from stats 1, they don't know about normal distribution. Then there they are lacking some lectures video, right? They are not able to get the content with the pace of the video. That's why we have added, so that you should get some idea. So accordingly, also we have added in additional content. So after the end term exam, you can prefer that additive property and all percentile. That will be helpful for you. Okay.
Okay.
All right.
Prashant sir, do we get interim break?
1 point. Can I?
Interim break.
Break for you are asking with respect to week, as they have given in maths 1.
No, sir, I'm asking about after the interim exam, do we have breaks?
50 to 20 days.
Unless and until they release the results, you have a break.
Yeah.
Oh, thank you, sir.
So there is no pressure of weekly assignment submissions after intermediate.
At least for 20 days. At least for 20
days. Thank you.
After this,
I thought it is continuous churning for all.
After 1st September, let me clarify. Do not think you have not to submit the week 12. Okay. For your end term preparation, I would suggest you to submit the week 12. Okay. Do it on your own. Okay. If you'll copy and all.
Sir, week 12 up to graded assignment 10% weightage. Out of 10 graded assignment for
they are
graded?
taking the, as per my knowledge, they are taking the best 10 out of first 11, I think.
That is what actually I have query. Then what is the use of 12th graded assignments? Is supposed to and
somebody
if
has,
I
for example, somebody has missed one assignment. Okay. So it will cover up in 12th, week assignment.
No.
That's not
the case.
That.
Okay. Let me share my screen and let me open the grading document. Then 1 second. Let me go to the stats 1 part. I will explain you in a minute, and after that.
But why I'm asking this, previously I got less marks in graded, and if I score 100 mark in week 12, obviously I'm expecting that 12th graded assignment has to be taken.
Is my screen visible? Now you can see. So actually, while they will calculate the final score, right? T score. the score which you will should get after the all the exam. So this GA they will take average best score in like best 10 out of first 11. Okay, you can see this week 12 assignment is not included in GA, but this is important for your interim exam. So it's important if you see, if you practice, if you submit your graded assignment of week 12, that will not be considered as a for GA, but it will be helpful for your interim exam. Okay. Understood? So first 11 out of first 11, they will take best 10. Okay. Fine.
Got it, sir. Thank you, sir.
On activity 4, we still have a problem of accessing the peer review section.
No, sir, it's now open, sir.
Resolve, sir.
It's a
open
resolved
It's open.
in the
Now,
evening.
now it's working. Now it's working.
Activity 3 was open few days back. Now 4 is still.
No, today itself in the
Today.
evening, right? Tech team
Sir,
will
check
call
it now,
test.
working.
Yeah.
Could you,
It's
what you
okay,
can do?
sir.
Can you please refresh and just try once again?
Yeah,
Sir,
I
I
have
have,
checked. It's not working.
Now I'm submit the peer review. And
Yeah.
sir,
Sir.
I have one complaint. Sir, my activity is being copied by other students.
Okay, that things will take care of it. No need for it.
So no,
Yes.
like if my marks will be deducted for that,
No,
like
no,
he has copied.
no, it's not. Your marks will not be deducted. So thing is that for the extra activities, so main idea was to you should take
Understand the concept.
Yeah, correct. Understand the idea behind this. Maybe you have seen that when your n will be large, p will be small, that binomial will approximate to Poisson and all. So how you can see with the real life data and all. I think so. These kind of things, how to do pie chart. If you have been given the data, so you should understand whether it's a categorical or numerical. Why is it important? Suppose you have been given gender data, let's say 0, 1, 0, 1, 0, 0, 1. 0 is for female, 1 is for male. And we asked do some EDA, basic summary of that data set. And you calculated an average and you tell me average of this is this. So that's meaningless, right? For gender data and all. So that extra activity we gave so that you should get some idea along with some real life data.
Sir, the thing is,
I even, sir,
only
I have while I was reviewing, sir, I have seen two of the person, they have copied each other, sir. So I got confused, like which which person has
who is
copied
the
from
owner?
which one? Yeah.
No. So okay, for that particular person, what you can do, just give the marks as per the activity they have done. Copied one, we will take care of it. Okay.
Okay, sir.
But how will you? Which one is copied?
How will we differentiate? Yeah.
Yeah, that's the. So
that is a question mark for everybody.
Yeah.
So thing is that
So
okay,
is
so
why I
what you
asked,
can do, so I would suggest just give them marks as per the activity they have done. Okay, for copying we will take care of it. Okay.
How did you know it's a copy? We don't get an access to everybody. You have been given through 2-3 people.
Like how did that happen?
Sir,
how did we get to know that it is a copy of somebody else?
No. So thing is that suppose me and my friend did together.
No, that's
no, sir. What I
as a student, we don't have a look at all the people to say that I can compare.
Correct.
People to peer review. Unless I find among
both copies.
Three, and out of the 3, I find 2 identical.
Yeah, then you can say correct. Then you can say it's a copied.
But that's not.
Prashant sir, as you are allowed to take data sets from internet, so then it may be copied.
No, data
set.
Data
set can be the
if
same.
you are doing your personal, if you are doing
analysis could be different.
Yes.
Yeah, analysis can be different, and whatever the conclusion or statement you have written, that will be different. Okay.
Yes, I have also seen the same data set.
In my case,
okay,
sir,
so actually, okay, one more thing. Let me
answer.
So,
in my case, sir, when everything word to word, data to data, graph to graph, everything has been copied.
Oh, is it? Okay,
Yes.
So we'll see. We'll try
If
to
you
come
want,
up.
sir, I have the link of mine, and he's also. If you want, I can share it.
No, but the other person's review came to you, is it?
No. The some other guy who knows me sent me the link. That look, he has copied your data.
Oh,
Don't know. So we'll see. We'll
And
see
sir,
something
and
which
sir,
should
what
be.
about the comments, sir? People are commenting are just like, I mean, one people
No,
have
no, that is
commented
actually.
in Hindi, sir, actually.
Yeah,
Ek-
Biswajit, I saw. I think you sent
yeah, you're
one
right.
mail, right? To me, if I'm not wrong.
Vishwajit,
So
this is happening to you only, I hope so, because you have a lot of fan base, I hope so.
no, but it shouldn't be this kind of comments. Actually, fan base. Okay, so
Yeah, so
we'll
maybe.
there should be. We'll try to we
Okay,
discuss
sir.
with the team. There should be some guidelines and all. If they someone is someone is doing someone is doing these kind of things, we will simply give them zero or we'll take the
I
something.
have the link, sir. If you want, I can upload it for you. Like you can verify it.
Yeah, you can share with me by
Hey,
mail.
for a long time, Pramod Bharati have raised the hand. I don't know. He's not speaking, but
Is it?
Yeah,
Yeah, please go ahead. Yeah, what is?
I am listening to all the discussions and debates on
you're saying
the weekly
Proton, is there?
extra activity. Actually, I have a request with sir that if possible, please give some important topics from week 1 to 8.
For end-term preparation.
Yes, because I think it won't be possible for me to go and revise each and every section of the from week to 1 to 8 due to some of my personal
Prasant sir,
reasons.
that is the reason I requested initially. That is what is the concern also.
If even there will be some hint that okay, these topics are important, these are mandatory that you have to go to these topics, then it will be really be very helpful, sir.
Okay. So
Excuse me,
So
sir.
that is why
Sir,
actually I requested Prasant sir to conduct mock session so that
sir,
he will give all the hints.
so okay. So thing is that
sir, is the
you
discussion
can.
completed, sir?
Sorry, this.
Sir, is the discussion completed, sir? I
Yeah,
mean, we were
You can.
discussing.
You can. Yeah, you can leave. It's
You can
already.
leave, please.
Sir, it's not about the leaving, sir. Actually, I asked a doubt at the initial phase, sir. So I asked
Jeet,
you that can
yeah,
I
that's
ask
what.
the
You can
yes,
share
sir.
with me, but I would suggest TS will take care of it because it's already about 11. So anyway,
Oh, all
okay.
right, sir.
So
All right, it's
okay,
okay,
what
sir.
you can do, just do a mail to me. I will check. Okay.
what is week 1 to week 4 you're saying, sir?
All right, sir. Thank you,
Like
sir.
there is syllabus from week 1 to week 12. Okay. So from week 1 to week 4, you can go with the some like correlation and all. Okay. That from week 3 mean variance and all, these are the important. You can check with that. So from week 1 to 4, one thing I can assure you, if you have done the practice assignment, right?
For all of the week 4s.
Correct. So
Practice
you can.
assignment for week 1 to week 4.
Yeah. So
Yeah.
that will give you the more idea. Anyway, regarding the
Okay.
important topics and all, I will come up in the next session. I will go through the question
Okay,
paper
sir.
once.
Thank you.
And
Thank you very much.
Okay. Thank you. And one
Sir,
more thing, sir.
yeah.
sir, one
Sir,
request
just
from
we were going through the normal distribution, and as we know that if data is really large, so in most of the cases it will converge to a normal distribution.
Yes.
But what if any of the variable which we have to consider for a particular data set are sparsely distributed, are sparse in nature? Suppose I have 10 variable. I have 10 variables and some single variable or two variables are such that they are very sparse. So whether they will be also considered to be following normal distribution, or we have to do some kind of iteration to make them normally distributed before feeding in proceeding further for the analysis, or whether we are going to use machine learning or deep learning algorithm on that particular data set.
No. So first, correct me whether I got your correct question correctly. So you are talking a single variable is mixed, right?
Suppose I have a data set which have 10 variables. And one variable, for instance, one variable in that particular data set is sparse in nature.
Okay.
So most of the data are zero or absent, or somehow it is sparse in nature.
Okay.
So in that particular, and that is an important data for important variable for the model building. So in that case, as it is true that if data is not normal, we can't use that particular data for most of the models.
What do you mean by sparse in nature?
Yeah,
Sparse
that's
in nature, most of the rows are empty in that particular case.
Oh, missing.
okay. Oh, okay, missing.
Missing,
Okay.
not, it is absent. It is the nature of the data is such that it is absent in many cases. Suppose if you will see the hourly or 2 hours data of a meteorological department, you will find such kind of variable. There are 32 or 33 data variables in total, and some of the data there are very sparse in nature.
Okay, if the data is missing, how can we can
Name, it is not missing. It is absent.
absent is
It
missing?
is not means
Don't
missing
have it, right?
means two things.
No, wait a minute.
Missing means two things. Either it has not been recorded due to some fault, or it is absent as because it does not require such a frequent updates.
What I mean by absence is if it is not available for analysis, how
That particular time, that particular duration,
see
or
that
that
parameter,
particular
that parameter
row.
is not fully available, so we cannot make an inference. So any attempt is to that extent limited.
Yes.
No, but
Also,
there.
thing is that is happening because of suppose you are doing some census, some
Census,
survey and all,
this is an
and
example.
correct, and you went to that particular house and all. Okay, and you want suppose you asked or that suppose
Income.
there is
Suppose
correct.
everybody
Yeah,
doesn't disclose the income, so then you may not be able to come to a consensus. Or
No. But there are various combination, because in census there are multiple variables from which you can at least impute the missing income data.
yeah, that's
Because I
okay.
have done,
So
I have done some projects with the government of India. There we used to do when we do the primary collection of the data from the ground, from the ground, we came across such kind of mismatch, and just we cross check and we impute the missing data in that. Now, that is not the case. That I am not worried about. I am worried about that
like
if data is sparse in nature in any of the variable. If we I am doing some multi variable model, and in that particular case, if any of the variable is sparse in nature for any reason, then how we are going to proceed? We have to make them it normal before proceeding, or we can just take that variable as it is in the data set and proceed with the further work on that.
so like lots of approaches are you can fill with the some, like first of all that data you can fill with suppose if mean is appropriate for example. Okay, it will depend on the what kind of variable you have. So you can suppose you fill suppose you are as an analyst usually at this value if I will fill with the mean for example, you don't want to delete or deleting is not a good idea for example, then you can fill with the some average value and then you can go with the further analysis and all. Okay, but if it's suppose there is very less missing and all and you feel yeah, if you will delete that particular row or that particular observation and as per your prior experience and all it will not
It
affect
won't affect
the
the.
final result with that much error. Some sort of error is okay, right? So we can go with that actually. So actually what how you can fill with the no sometimes mean
Yeah,
some
there are many method.
median.
Yeah, there are method.
Yeah, you
Yeah,
can
yeah.
something
Huh.
called mode, and you can go with lots of method and all. You can do NLP and all, but you will go higher and all. Okay, that's called, you can do another thing. You can do transformation and normalization and all. Okay, so basically you can encode the variable and then you can proceed. There are lots of procedure which
Methods, yeah.
in ML and LP. Maybe you heard about one hot encoding, label encoding and all.
Yes, yes,
So
yes,
this
yes, yes.
is applicable when you have categorical variable, like
Yes.
so these kind of things useful. So that is something we'll will do
Okay.
in when you will learn MLT and all.
So one more thing I was wondering, we are going through a very intensive coverage of maths and statistics in these 8 month of course, but I still find one thing missing.
What?
That okay, these are the concepts which are needed very much for the success of any of the machine learning or deep learning things of the data science. But how the concept which we are learning is directly related to the data science field or the machine learning, or suppose we have studied the domain and range concept in very
Okay, so
extensively in
let
week
me tell you
2 and 3.
what the subjects that they have designed, right? Let's say stats one, maths one, and all. Okay.
Your voice
So
is
if you if you know about let's say basic statistics, right? So if you going to study about data science and all, okay, let me tell you one scenario. Suppose if you want to learn stats 2, okay, then foundation for stats 1 is necessary. Stats
Mandatory,
2,
yeah.
stats 2 is we are moving for 2 random variable and we are moving for hypothesis testing, parameter
Basically,
testing and
basically
all.
matrices and all those things are
Correct.
in
Everything is
there, yeah.
important, because if you learn matrices and all, that calculus and all, derivation and that differentiation and all. So those differentiation, when you will move to machine learning part, right? So in machine learning we will see global maxima, global minima and all. So for
Yeah,
that
yeah,
particular
yeah.
part, you should know what is the differentiation. You should be aware about
Yeah,
what kind of function x
integration,
square
yeah.
look like, x cube look like. And if you know that, then you can do the easily. And regarding the stats part, if you move to the suppose any kind of today's lots of large language models use this probability part. Okay, suppose you are going to predict the next word, then what is the probability uh, for that particular term and all, right?
Word, yeah.
So that probability is very very important also. Everything is important. Okay, so everything is actually interconnected. Suppose you want to
Yeah.
understand what is the central limit theorem, right? To understand the central limit theorem, you should know the normal distribution, you should know the other distribution, you should know the how to convert in standard normal variable. So these all things are very important. So you in start, so you will learn, let's say, Markov inequality. So Markov inequality, in which scenario you should Markov inequality, in which scenario you should Savicey inequality. So whenever you to move the machine learning part, right? So machine learning part is the combination of stats and math. Okay, you should know
Yeah.
the vector space. You should know the what is the role of eigenvalue, what is the role of eigenvectors and all. Okay, when you will to move the ML part, I mean EM algorithm, MM algorithm, you will see. Okay, in machine learning techniques, you will learn about Gaussian mixture model. To know the Gaussian, say Gaussian is nothing but another name for normal distribution. So
Normal
to know the
distribution, yeah.
mixture model, you should first know the what is the Gaussian, right? What is the normal distribution? So all things are actually related to each other. So basically, from here onwards, you are it's kind of, you can say, paths to reach till that point. Maybe I hope given the answer for question. Okay.
Yes, sir. Okay.
Okay, so if
Okay.
that's okay, so can you wind up? If it's not, it is
Yes,
fine
sir.
to all of
Yes,
you.
sir,
Okay.
Sir,
please.
yes, sir.
Yes, sir, sir.
Sir, at the beginning of the course, sir, even I have the same doubt, sir. Why we are company will not ask do the I mean descriptive analysis or maybe something like that.
No, this is it.
So
So for okay, suppose we didn't teach you about what is the descriptive, sorry, what is numerical data and categorical data, for example. Okay, and there is a okay, now is fine.
Yes, sir.
but sir,
Okay.
I now right now I realize, sir, these are all the steps, sir. Actually, from like if you wanted to learn English language, you have to start from the A, B, C, D, then making word,
Correct.
and after that.
Correct.
So
Correct.
that's how I realize, sir. But I have a complaint, sir. Like in US, if you see, sir, the trend, many trends are changing, sir, actually. And we are not opting all the trends. For example, quantum computing is right now necessary for the data scientists, sir.
Yes,
I haven't seen any course, sir, in this. In BS course, we don't have any quantum computing, sir, subjects.
Actually, so thing is that this started in 2021 itself. Okay, so there are lots of elective subjects in coming in degree level and all. So we can suggest them to come up with some course related to this. Okay, so
Yes,
maybe
sir.
they
I have
are
read many articles, sir, where like
okay.
what are the topics we are discussing right now, sir?
Correct.
It had already discussed in US at 2010, sir, 2010, 11, 12.
Yeah, understand. I can understand actually.
Sir, we are very behind, sir.
I
So
can convey this idea to the
Quantum machine learning is completely in a very another sphere. I have done one just certification course on that from IBM on quantum machine learning. It's all on in machine learning, which we are doing. We are converting each of the data in zeros and ones. But in quantum computing, there is nothing like zeros and one. There is everything is zero. That is the difference. And so each and every model which we are using here, the same model is there, but it is customized to that particular hardware, that quantum machine. That is the main difference. And the fundamentals which we are learning or which we will learn here for model building, model deployment, each and everything are similar. But the concept which we are learning, that will remain same. You have to customize it according to the hardware.
Yeah,
We are
Pramod,
using.
I totally agree with you. I totally accept
Yeah.
what you have said.
So,
but I am saying that in advanced courses, I'm saying that in advanced courses, when we go to like in our third year or fourth year level courses,
Fourth year.
we have to add this kind of courses so that we have to be at par with US universities.
Yeah, no
So
issues.
US universities are
don't
also
worry.
not, sir, there are many specialized thing. Once you are comfortable with the basics, you are ready to run
Correct.
on anything. Either you are going for probabilistic machine learning or for federated learning, any kind of thing. This which I have done 2 masters already way back in 2003. I have completed my 2 masters, 15 to 17 years of work experience in research field only. After that, into 2021, when IIT Madras came with this particular program, from that time I was wondering whether I should get enrolled in this or after 2 masters, or whether I should pursue for my PhD or what. Due to my health issues, I can't do anything for last 3 years. Lastly, in March, after which my health improves, I decided no. First, I will go for the basics. This is very important.
Yeah, basic is important. The foundation
This is, I have done numerous certifications and MOOC from various universities in Europe, US, some institutions MOOCs I have done in these 4 5 years. And lastly, I came to the conclusion that until and unless you are very strong in math, you are very strong with the statistics, you are very strong
that
with
is the
programming, you are not going to move anywhere.
So
You
that is
have to
very, very
completely
important.
focus on these 3 aspects.
Correct. So these are the actually kind of, you can say,
Pillars.
pillars and a bridge for that. So I will convey this with the authority. Maybe they will think about this. So okay, all right, then can we
Okay.
wind up?
Yes,
Okay.
yes, yes.
Good
Sure,
night.
sure,
Okay.
sure,
Good night,
sure.
sir.
Okay.
All right,
Bye,
then.
sir.
Thank you all.
Okay. Thank you, sir. Good night, sir.
Thank you, sir.
Prashant, sir.
Where do we get your email ID?
It's prashant@study.iitm.ac.in.
Ilengo, I have already shared with you.
Yes.
Somebody sent it to me. Thank you.
I'm sharing a link. You can I'm sharing a link, WhatsApp link. You people join that link. I will share all. I mean, sir email ID over there.
Okay. So only Prashant email ID, right?
Yeah. Just a second, I'm sharing the link.
Okay, Vishwajit, Bhaskar sir, I'm leaving. Good night.
Yeah, good night.
Good night.
Bhaskar sir, give me.
Yeah, I'm waiting.
Just a second, actually, because
I'll give you my number. You can send me a message.
okay, sure.
Thank you.
Just a second, I'm just